Thank you for attending for today's PAM Technical CPT seminar. As we are about to begin, please be seated. Okay, salam sejahtera and a very good morning to all. My name is Architect Chu Heng Hua. You can call me Daniel. I'm your MC and moderator for today. On behalf of PAM, we welcome you to today's PAM Technical CPT seminar. Please be advised that to scan the QR code at the registration counter and to sign in and record your presence in order to claim your CPT point. Allow me to read some housekeeping notes. In the event of emergency, to evacuate the building, please use the exit by the nearest staircase, following the exit sign. And remember, avoid using lift. Kindly switch your mobile phone to silent mode to allow full attention throughout the sessions. And if you are not feeling well, kindly advise to wear masks. And if you need any assistance, you can reach out our project officer over there. For their support, and we would like to invite our sponsor representative to have their product presentations, Ms. Hailey Ismail. Please welcome.
Good morning, everyone. Is this loud and clear for everybody? Okay, thank you. Wow, quite a turnout. All right. Thank you very much for coming today, and I'm very, very pleased today to share with you a little bit about Knauf Aqua Panel. Aqua Panel is a pretty recent product lineup that we have included in within Knauf. So without any further ado, let me just start. Okay. Let's talk about the product structure first and the market segments. Okay, let's understand what is Aqua Panel. Aqua Panel is actually a cement board. If you can see here, how to differentiate our cement board, Aqua Panel cement board from a normal fiber cement sheet board. Fiber cement sheet board would not have any mesh. So the distinct feature with our cement board is that it is made out of Portland cement board, and then it is wrapped all around with a mesh. So this mesh is embedded slightly embedded onto the coating of the board. So this mesh holds its board into its place. So it acts as it gives its resilience. So the difference between our cement board and also fiber cement sheet board typically contains organic chips inside it. So with it having organic content with it, it absorbs water and swells. Where the difference between ours is that we do not have any organic content, so therefore it does not absorb and it does not swell. So it retains its integrity, it retains its shape. So you don't have any expansion and very minimal expansion and contraction with our cement board because it's purely inorganic. So the other difference with our board also is that we come with a full complete system, meaning that we have the jointing tape and also our compound and also surface mesh and also skimming, all within one proven complete system. Whereas when it comes with fiber cement sheet board, you require a different system to make it complete and whole. Where can you apply it? Typically anything, anywhere. So to sports facilities, to hotels, to public buildings, to office buildings, and also residentials. Okay, let's understand its features, benefits, and what it can do for you as an architect. So, like I said, it's 100% water resistant, so it doesn't swell and it does not lose any stability. It's very good in terms of for an external use because it's resistant to moisture, weathering, and mildew. So, and it's a very stable product because it's made out of Portland cement. And the good thing about it, it can curve. So it's really safe and hygienic, especially for hospital use. And it is rated as the highest non-combustibility in fire standards, and it's a very strong and high impact resistant board. Okay, as mentioned, it can curve. So as a full board, it comes in 1.2 by 1.2 by 12.5 mm thick, 1.2 by 2.4 mm size, length and width. It can curve up to 3 meters. But if you require anything smaller than that, all you have to do is segment it. So when segmented it about 300 mm segments, it can curve up to 1 meter down. So basically, as an architect, you would love this because it gives you design flexibility. Okay, let's understand how it can curve. So basically, using our framing system, you at a certain radius, at the radius the requirement that you have, you place in our flexible track and secure it onto both at the bottom and at the top. Okay, and then you put in the vertical elements in at a closer interval. Normal drywall will require about 600 mm studs spacing, whereas when it comes to curvature, you may require, depending on the radius, at a closer interval. And then before you apply the board, you have to pre-band the board. So loosen the edge, soften the edges first, pre-band the board, and shake it loose. So this is already making it able to curve. So then you start to drill it onto the stud system. You don't require any pre-drilling, so drill it immediately onto the board, onto the framing, and as you go along, gently bend it according to the curve of the structure. So each boards are laid horizontally and there's no cross joints. So you have to have it in a staggered manner, just like a typical gypsum board drywall installation too. Okay, with our boards, with gypsum, like any typical fiber cement sheet board, it can receive any kind of finishes, be it painting or rendering, and also can support any weight from any cladding materials that you require on top of it. So typically there's two types of wall solutions that we offer. It's either as a facade or as a typical drywall. So with our, together with Knauf profiles, and also our proven system in completing the drywall using the jointing treatment and also surface mesh and skim coating it. Additionally, it can also be applied as an external sealing system, very good when it comes to, especially when it comes to weathering. And we come complete with certification. So this is our building material class A1 according to the EN standards, and our class, our Bomba class O is already in progress. We are close in getting it to meet the standards of BS 476 Part 6 and Part 7. And we are classified as safe from VOC, from the Health and Building Biology report. And we do have the environmental product declaration and also the LCA to support it. And we are also classified green by Singapore Green Building Product. So let's look into some project examples within the region. So this is a project in China. As you can see, whatever that you can see here are done by external drywall by cement board. So this is where you can see the progress of the board curving, concaving, and convexing within the same panels. And then this is another example where it can receive cladding materials on top of it. So this is a Catalytic Experience Center in Shanghai, China. Okay, let's understand why Aquapanel versus the conventional exterior wall system. So these are the benefits that you get. The summary, let me go through one by one. So as I mentioned, the versatility as an architect. You would love it because it can bend, not other than it can receive numerous kind of finishing and coatings, it can bend, so it is a very good product as a facade, as a decorative building elements, non-structural, and it can, last but not least, it bends up to 3 meters when it comes as a full board. But obviously, as I mentioned before, anything that is smaller, it is also possible. And then it offers 10 times lighter when it comes to exterior wall structure. So because of this, it makes it, the structural cost is highly reduced, and it avoids, and during refurbishment, you do not need any structural reinforcement. So also from the flexible system design, we can cater to any local wind load requirements, and from our framing system, it's also good for seismic metal, for earthquake use. Okay, it's also 6 times faster in external wall construction. So how? Because through its facade, through the drywall and facade can be done single-handedly by one trade, so it simplifies the construction process. And then you don't need any pre-drilling, and the cutting of boards is just simply through scoring and snap techniques, so it gives easier handling for the contractor, so it hastens the construction process. And the very good thing about it is you can close up the building envelope faster through the joint treatments, and then this speeds up the construction process, making it very efficient. Okay, we also use 50% less primary energy requirement during manufacture, because our boards are, in terms of production, it is 30%, it is energy efficient by 30%, making it lower in terms of CO2 production. So we prioritize in material efficiency and also waste reduction, because we gave 50 years life in terms of service lives, and also 10% of recycling materials, of 10% of recycling content. And we prioritize also in terms of protecting the occupants' health, because it strives for good air quality and also combat moisture. And it gives a faster payback and a higher return on investment through the lower cost, construction cost from the shorter duration, shorter construction period, and then also it increases your rental gains, because through of the thinner and lighter, because it gives you more space, right? And then also lighter to the foundation cost, and then through this cost, high reduction on structural costs, you gain these significant financial benefits, both in terms of construction costs and rental value. Okay, we have many high performance benefits from it. One of it is that through the ductile behavior of the framing system, it is very good in terms of seismic design, and through the system makeup, it is a weather resistant system design, because it also covers it from under any water seepages and a good water tightness, and it is tested from for fire rating. It has low U value, so therefore it makes it high energy efficient. And through the makeup also, it also offers good acoustic insulation. Okay, with the low U value, as you can see here, for drywall, right? It makes the building, it insulates the building, so it doesn't require any high cost of energy to cool down the building. So in other sense, it makes the building efficient in terms of cooling down the building through the low U value. So let's look into a case study that we have. I find this very particularly inspirational because of the capability of the boards. So this is in Chile by Patterson Fox, utilizing about 100,000 meters square of boards. So what the architect envisioned was this tunnel. This is just before you enter the train station. So this is at Tobalaba Metro, curved tunnel before you enter the station. So it's a series of curved panels throughout the tunnel. So from the initial sketches, they envision how to achieve the curvature of the boards, and then reviewing through design. And then from the case study, from the flat panel, from the blueprint of the flat panel board, they studied how they can curve it through segmentation. And then from the board, they studied how they can form the structure, the substructure to create the curvature for the boards. And from there, they created a mock-up with the base substructure and applying the board segment by segment, finishing up the boards, and finishing up the joints and also finishing up the boards. So this is the final mock-up, which they brought it to the presentation to the architects and also did on-site training. And with the substructure being placed, they start to put in the boards and segment by segment, treating the joints and putting up the surface mesh. Moving along from board to board, panel to panel, to the finished product. And that concludes my presentation. Thank you very much.
Okay, thank you, Ms. Hailey, for the interesting presentations. Okay, without further ado, let's invite our first speaker, Mr. Brian Wong. He will be presenting a topic of building sustainability through environmental product declaration, EPD. Mr. Wong.
Hi there. Good morning, everyone. Good morning. And my name is Brian. I'm from Kuala, and it's my pleasure to be here and to share with you some of the interesting topics. Some people find it new, some people find it boring. So I hope that what I'm going to share later is something useful and beneficial for you in the future. So the title today is Building Sustainability Through EPDs, right? And these are the things that I'm going to cover. 10 main points, from climate change to the carbon footprint, what is embodied carbon, LCA, EPD, and then we'll finish off with some examples to share with you. Now, before we start, can I have a quick show of hands, just to warm up a little bit? Right? Can I have a quick show of hands? When we talk about EPD and LCA, Environmental Product Declaration or Life Cycle Assessment, LCA, from a range of 1 to 5, 5 being the best, or you know it very well. Any one of you who think that you are at 4 or 5? Anyone? At a 3, maybe. 1 or 2? You guys are just too humble. All right, so let's get started, right? The first thing, we start off with climate change. Why we need EPD and what causes all this and what are we experiencing throughout, right? So the first thing first that comes to our mind is the greenhouse effect, right? So if you look at the screen right here, it says that the solar radiation, supposedly when it goes into the Earth atmosphere, part of it will be reflected and some of it will be reaching the Earth's surface. However, some of the infrared radiation passed through the atmosphere, the ozone layer, and then it was then somehow trapped by the greenhouse gases, okay, and the greenhouse molecules. What is the greenhouse gases? I will cover that shortly in the following slides. By trapping in all this radiation from the sunlight, it creates the greenhouse effects, it creates the rising of temperature in the environment, and it warms the Earth's surface and lower down and on the lowest atmosphere of the Earth, right? And then this is how we put into the perspective of our real life, right? From deforestation, from the use of chlorofluorocarbons, oil and gas, from combustion, from vehicles, and also industrial development along the way. So all this contributed into the greenhouse gases and causing the climate change in our environment. Now, there are some studies that showed, right, if you see the chart over here, you see the spike. The spike actually started in the 1950s, where the evolution starts. If you look at the chart on the left-hand side, I'm not sure you guys can see it clearly. The rise of GDP increased tremendously starting in the year 1950s. The same goes to the, oh, where's the pointer? Okay, here. This is the real GDP. Okay, use of energy, there's a big spike. Okay, water use, paper production, and all that. So all that are experiencing a big spike starting in the year 1950s. And that causes some changes into the earth. Right, the surface temperature has gone higher, methane has gone higher, ocean has become more acidic, and so on. And there's a saying that if this climate change continue to rise, right, it could cost global economy of US dollar 178 trillion over the next 50 years if we do not do something about it. Right, and then when you talk about temperature, look at the average between the year 1950s until the year 1980s. This is taken as a benchmark baseline of the average temperature. Look at pre-industrial temperatures, they are lower, but now, on the recent years, it has gone up much higher. Global temperature is on the rise. And that brings me to this photo. One of my favorite photo. Look at this, is year 2006, yeah? Right, we are wearing this already. Now we are what, almost 20 years later. This is an old photo, by the way. So what are we wearing right now? I don't know, right? So let's carry on. Now, when the Earth sea level rises because of the melting of the Antarctic ice and all that, seaside cities may submerge into water, including KL, places like Bangkok, places like in Singapore, Jakarta, it may be submerged into water in one day if we do not do something about it. Right. Other geophysical and societal impacts includes rising of temperature in heat waves over here, rainfall, abnormal rainfall, typhoon that we have experiencing in our neighboring countries nowadays, right? Increase in the frequency and the amplitude of the extreme events. Seaside sea level is rising, right? Ocean become more acidic, coral reefs are dying, right? And biodiversity collapse. And all this is causing what? Water shortages, decline in fishing yields, agricultural yields declined, migrations, and of course political and financial instability and insecurities, war perhaps. So these are some of the extreme scenarios that we're projecting. Not that it is happening, but some are slowly progressing into that kind of direction already. So then comes to the word sustainability. It has been a popular word. It could be, it sounded very vague to someone, right? It says, according to UN, sustainability means that a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Right? Sounds, right, very big, isn't it? So what does it mean? Does it move? Okay. Sorry, yeah. Battery out. The next thing I want to talk about, the next slides, is about Paris Agreement. You guys heard about Paris Agreement? Let me show you shortly. Thank you. Still cannot. Oh, okay. A bit slow. Still cannot. Or maybe let me use the mouse. Yep, yep, okay. Oh, Miss Organizer, do you have a mouse? I can just use the mouse, it's okay? Okay, now we're back. All right. Sorry for the slight technical glitch just now. So what is a Paris Agreement, right? So as you can see from the screen, it's a legal binding treaty, right, to combat climate changes. It has been signed by over 190 over countries. When? 2015, right? And in Paris, and it come into effect in November 2016. So what is it all about? Maybe I just play the video. I let the video do the talking. This is a short one. Can you help me to play the video?
Preferably to 1.5 degrees Celsius compared to pre-industrial levels. This requires economic and social transformation to face the climate.
Sometimes technology can be complicated. Is it okay? If not, we just skip the video, it's okay. All right.
What is the Paris Agreement? The Paris Agreement is a legally binding international treaty on climate change to limit global warming to well below 2, preferably to 1.5 degrees Celsius compared to pre-industrial levels. This requires economic and social transformation to face the climate challenges now and moving into the future based on the best available science. The Paris Agreement works on a 5-year cycle of increasingly ambitious climate action. By 2020, countries communicate their plans known as nationally determined contributions. Countries communicate actions they will take to reduce their greenhouse gas emissions in order to reach the goals of the Paris Agreement. Countries also communicate actions they will take to build resilience to adapt to the impacts of rising temperatures. This may include information on adaptation and finance flows. The Paris Agreement also provides a framework for financial, technical, and capacity building support to those countries who need it. Starting in 2024, countries report transparently on actions taken. Collective progress under the Paris Agreement will be assessed through a global stocktake. This will lead to recommendations for countries to set more ambitious plans in the next round.
All right. All right, back to the slide. Now, in the video, if you notice, it says that the goal is in combating climate change is to reduce the global temperature increase to be not more than 2 degrees Celsius. Okay, it could be 1.8, 1.9, but preferably not more than 1.5 degrees Celsius compared to pre-industrial levels, which is around the years of 1850s, back then, back to the before the industrial evolution. Now, the starting point is somewhere at the blue line over here, right now. And in order to reduce the global temperature from here all the way to 1.5, okay, it needs to be a reduction of 35 gigaton of CO2 equivalent per year. So by some calculation, because right now here we are at about 55 gigaton of CO2 equivalent per year emission on Earth right now. So in order to achieve a cooler climate, in order to reduce the increase down to this range, the objective and the goal is to reduce 35 gigaton of CO2. And how do we do that? Right? So now in Malaysia, as part of the member who signed this treaty, we have actually set up quite an ambitious goal. Okay, it says here that, right, Malaysia, we have a okay, Malaysia pledged to achieve carbon neutral by the year 2050. In the APEC region, it's one of the most aggressive decarbonization plans that we have throughout compared to other countries. And other master plan that we have, including, developing green mobility solutions, vehicles, and stuff like that, building sustainable and resilient cities, and also developing a circular economy. More and more recycling and reuse plans will be employed throughout the years from there, right? In comparison to other APEC countries within the region, the blue line shows the emission in the year 2018, and the green bar shows the 2010 emission of an 8 years gap. You look at the 8 years later, the emission is higher throughout across all countries. Malaysia is pretty low compared to the rest, right? But still, it is still on the high side, right? So some of the key strategies in Malaysia Climate Plan 2050, DBKL first started off, right? So and they want to reduce emission by 70% in the year 2030, and hopefully 93% in year 2050 compared to the baseline of 2010 levels. Quite an ambitious task to take on, and something closer to us in the construction and building industry. Look at the box in red. One of the strategy is to employ energy efficient and climate proof buildings through low carbon building checklist validation, something related to what we are talking today later, building performance, benchmarking and rating, and near zero emission building roadmap. Okay, how do we achieve that? What I'm about to share shortly is one small step in getting closer to that. Okay. So now, we all talk about energy consumption all this while. How to be energy efficient, how to save electricity. So let's talk about it. In Southeast Asia, okay, building consuming 30 to 40% of total energy used. Let's compare Singapore and Malaysia. Right, in Singapore, we are both the same. Industrial, both occupying 48% of total energy consumption, whereas the rest, buildings, is about 50%. Commercial, residential, household, and buildings, more or less the same. It is occupying half of the chart from there. However, energy efficiency could be just not enough. And we need to talk about carbon footprint. Why and how? Now, we all always talk about here in the past. We talk about how do we decarbonizing the energy, the use of solar, how do we save electricity, how to save power and stuff like that. But then now, people slowly move on to the term called embodied carbon and carbon management. Okay, so embodied carbon to start off is simply the next level in energy efficiency. In short, I call it EE. Okay, and decarbonization. How and why? Let me show you. Now, like what I said just now, building carbon footprint, the building itself contributes about 40% of global carbon emission, right? 28% coming from the operational emission. Means that the way we switch on our lights, the way we operate the building, okay, post-construction, whereas 11% of it come from materials and construction. Whether or not it is a new renovation infrastructure, it doesn't matter. Total, it makes about 40% and all that. And that generates about 100 to 200 gigatons of embodied carbon along the way. So let's take one example of a building. This is by a simulation. For example, you have a 6-floor building, right? Floor area of 2,500. 50 years lifetime. And during this 50 years lifetime, how much energy has been used? Look at the chart right here. Energy consumption through the operation of the building takes up this much, about 60%. Construction material and manufacturing takes about almost 30%. The rest is the construction, repair, and demolition. So we always in the past focus a lot on this part, right? And this part, nobody really bothered about it. But is it enough of what we're doing right now to achieve what the Paris Agreement trying to do? Well, look at this circle right here. It is a continuation from here. These 2 bars, for example, right? Now, the green color means embodied carbon of the material. The gray color is the operating carbon, the energy used in operating the building. How you use the lightings, the power, and all that. So we always focus how do we reduce the gray color part of it. Now the gray color slowly through time, it has been successfully reduced. But the green color one remains in place. The embodied carbon, the energy, within the material itself is always there if it's not done anything to it. So what is embodied carbon? It is a CO2, okay, emitted from the manufacturing, transporting, replacing, and disposing of material of the building. So far, okay? Let's carry on. Now, what is embodied carbon and how does it work? Imagine if you construct a building from year 0 until you have the lifetime of the building up to 60 over years old. Right, how much carbon has been used from year 0? The material use. It's a bit small here, I hope you guys can see. Right, from year 0, the material use contributed the most significant carbon, followed by the transportation of the material and the construction of the material, all stacked up in year 0. Okay, and then following the energy, the green color bar over here, is the year-on-year energy use throughout. Look at it. So if you total up the green color bar, yes, it's quite high, right? But people are slowly reducing the use of energy, the operational carbon on this direction. But this direction, people tend to ignore about it. This is where we pledge to do something in our design, right? So in order to find out what is this all about, this is where the life cycle assessment of a material comes in place. It is a quantitative analysis. It has got a structured method to assess and measure, evaluate materials associated with all the stages of life cycle, from the raw material of the product, production, sending out to the project site, construct, disposal, and recycle, all the way, the whole life cycle of the product, right? So it is a science-based standard, right? Performance-based, neutral on technology, and it is very often holistic approach, okay? No sub-optimization. Now, these are the processes that I mentioned just now, starting from the raw material, the processing, manufacturing, and so on, right? So the LCA itself is a total environmental impact of a product from raw material, processing, all the way to the end of its life, right? So when we have the data of all these things over here, by breaking it down, we can tell which material processes in the value chain are most heavily contribute to the climate change, which process contributed the most carbon emission along the way. And that gives the benchmark for new manufacturers to make improvements to make the product better and greener along the way. Okay, now, a lot of time when we just look at the building material, okay, look at this. We have building 1, building 2, building 3 using different materials. It looks like based on the material that we use, building 3 is the best. It emits the least amount of carbon, right? If you just interpret from the surface, a bit more superficial part of the built material. But if you study through the life cycle entirely, the whole construction, the power that we use, the replacement, end of life, recyclability and all that, probably this one is actually not the best. Who knows? This one is actually the better choice to choose if you're considering the total embodied carbon that comes along with the product. Right. Now, LCA typically measure the impact through CO2. We all know CO2 very well, right? It is typically measured in the form of kg CO2 equivalent. But greenhouse gases comes in many forms. It could be from methane, chlorofluorocarbon, nitrate oxide, CO2, and all that. So in this study, they will actually convert all this into one single unit, which is expressed in kg CO2 equivalent. Right? So all the data that we're going to show you later, it will be expressed in kg CO2 equivalent. So this measures from the material manufacturing, construction, use, any renovation again along the way, use and demolition then after that. Okay, so this is the output of the LCA, what it tells you. All right, from the first one, global warming potential. In short, we call it GWP. We have ozone depletion potential, ODP, and the rest. You say this is all different kind of unit, yeah? Yep. But in the study later, it will be all converted into CO2 equivalent, so that everyone have an apple-to-apple comparison across different products and different types of material. Right. So, and then how do we measure? So according to ISO standards, what you see on screen right now is a standard measurement, and they call it the product category rule, PCR. Right, I will show the standard shortly. So basically what it says that it will start from the A1 to A3, the product stage. Raw material, where does it come from? Transporting to the manufacturing site and production. And then after that, it will be sent to the project site, install and assembly. Right? This is stage A. Stage B is the use of it. The usage, maintenance, repair, replace, refurbishment along the way, which takes up the most of the lifetime of the product. And then after that, C1 to C4 is the end of life. Deconstruct, demolition, transport to disposal, waste processing, and finally disposal, whether or not you want to go for a landfill, incineration, burn it off, and so on. So these are the 4 main categories in the life cycle. Sure, okay? And we will go around these 4 categories in the next few slides heavily. So this is how it looks like, the few pillars of the LCA, like this. Normally, for a product to do a EPD, stage A1, A2, A3 is a must. If someone presented you with an EPD or an LCA, first thing you need to look for is this part. What is the reading over here? Right? And then next, you look at transportation to the project site, the usage stage of it, and then the end of life of it. Okay? Let's carry on with more. Now, a lot of time, right now, before we have the EPD or the LCA, people focus a lot on operational energy used. Indeed, this is one of the considerations in the LCA, but it is actually taking up a small part of it only. What is more important is here. Right? We'll look into some examples shortly. First thing first, if an LCA that is presented to you, it only expresses this part. And normally this kind of assessment, we call it cradle to gate. From the production of it until it is ready to ship out, but not out yet. If it's covering the construction stage, it is called cradle to practical completion. Right? If it covers entirely ABC, cradle to grave, which is the most common one that people do. And then lastly, if it includes module D, okay, module D simply means benefits and loads beyond the system boundary. Okay, this one is called cradle to cradle. Like what I said just now, this is the production of the material, the usage stage of the material. This is the end of life, the disposal, and this one is how it can be reborn and reproduced into a new material again, right? So, but if we take away operational energy use and operational water use, the rest of it is the embodied carbon that we're all searching for. Got it? Let's carry on. Now, when we look at the EPD, you may find it like difficult to understand. Why is this so complicated and all that, so many stages, all that? Remember, if you go to the grocery store, you buy a can of milk and all that, look at the nutritional facts behind the label. Basically, LCA works the same way. It tells you where does it come from, what is it made of, how many percent, what is it good, what is it bad, and all that. So basically, it is like a nutritional facts, right? So it is a summary of materials of impact, okay, of a life cycle, that this LCA is actually independent, transparent, and verified. Okay? LCA, when it is being verified, it is become EPD. An LCA study is the study of the entire process and all the data collection. But when the LCA is being verified by a professional, it is then published as a published open document called the EPD. And the EPD comes with validity of 5 years only. Okay, it does not contain sensitive information. Okay, and it basically looks like this. Okay. Now, I think I will not cover this. I think I have mentioned enough about all this. The EPD basically use GWP. Right now, what I want to show you in the next few slides, I want you to pay attention to the data presented, particularly relates to global warming potential, GWP, which is the embodied carbon of that particular material. Right? So let's go into it. Right. The EPD is being produced, okay, through ISO standards. I mentioned about standards just now. So these are the standards that are involved. ISO 14040, 14025, and then for the how to present and data collection and presentation, it goes to EN standard and IOSET standards. ISO is more for the US market, but for Asia and APAC, EN is more popular in our region. And once the EPD is done, it will be posted and hosted by the program operator. Okay, there are two well-known general program operator is called EPD Hub or International EPD System, whereby if you are becoming a member and subscribe to their service, you can basically search any material that you want of their EPD online. It is hosted on the cloud. You can just type in whatever material that you want. It's all there. It tells you everything. Okay, how you use it, later slides I will show you how. Right, so in the EPD, when you are looking at it, there's few things you need to look at. First is the geographical coverage, the technical attribution of it, and the timeline. How far does this material travel? Where does it come from? What kind of performance of the material does it involved? And how much validity time that it comes with. Right. Now, in order to make use of the EPD, it should start early. Look at the chart over here. Right? Decarbonization potential halves. It becomes lesser and lesser after each project stage. And the chances to get products to be improved becoming more difficult. For example, at the early stage, if you want to pick and choose the right material through EPD, you can do it. But once you enter into the concept design stage, the chances become 50%, and then so on and so on. It's getting more and more difficult, right? So let me show you some examples of EPD and LCA that we have, right? How do we read and decipher? Each EPD for each product typically comes in a page of more than 10, less than 20 pages, depending on how extensive the material is. Let me show you the first one. Right, this is a glass wool insulation. I actually cropped this from the document. Okay, when you first got it, first thing first is looking at where the product comes from. Okay, for example, in this case, geographical scope, the manufacturing is in Johor, Malaysia, right? And then next, what is it? The declared unit, what are we measuring? It says here, for this glass wool material, the declared unit is 1 square meter of glass wool with this kind of thickness, with this kind of performance. Okay, if you have a separate EPD of a similar product, but measuring in ton, then you are not comparing apple to apple. So when you are comparing, making interpretation across different products or similar products, make sure the scope and the functional declared unit has to be the same. However, some people say, oh, what if the declared unit is 0.5 square meter only, but this one is 1. So what can we do? The result, you times 2 to make it equal, right? Right? So this is one of the most important things to look at in the LCA information. Next thing, in the EPD, they will also show you what are the materials that is being used, what are the recycled materials, what are the packaging, and so on. Okay, all these are not secret. These are all published data. And then this is where the chart looks like, the A1, A2, A3, all the way until stage C. Cross means that it is included in this EPD. Right? Geographical coverage, APAC. This means that this product and in this EPD is produced covering all stages across APAC location. All right? And then this is the result. Looks a lot of numbers, a lot of funny names, right? Don't worry about it. What you need to look at this part. We're talking about global warming potential, right? So zoom into GWP. GWP, they are typically separated into 4 sections, right? Fossil, biogenic. What is LULUC? Anybody know what is LULUC? Land use and land use change, right? And then the total of it. Okay, by reading at this total, it means that the kg CO2 equivalent is 0.75 for this product, for 1 square meter of this product. If you want to compare something similar, make sure you are comparing apple to apple. Okay? This is example number 1. Let's look at example, there's furthermore, right? So now, system boundary says that this EPD is produced under these standards and it is cradle to grave. This is a summary of the CO2 equivalent that were mentioned just now, right? And most importantly, ensure your EPD is being verified. A good EPD must be verified by a third-party consultant verifier, right, like this. In this case, the third-party verification is done by Bureau Veritas, in this case. Right, the few important elements of an EPD when we look at it. Let's look at the second example. This is a cement board made from cement. The location is very different. I'll show you a different example, how it looks like. First thing first, this is the first page of the EPD of a cement board. Look at the validity date, 5 years. Make sure it is not expired, right? And then this is the declared unit, 1 square meter of cement board, aqua panel in this case, right, with a thickness of 12.5. This is the measurement that is being taken into account in this EPD. What's next? It is being verified according to standards by this guy over here. Next, again, lots of numbers, but how do we read out of it? Okay, as I tell you just now, first look at the stages over here. Very different from just now, isn't it? Cross means those EPD that are being studied. This is included, this is included. However, stage A4, A5, B is not included. It says what? ND means not declared. MNR means not relevant for this particular product. So in this EPD, it only captures A1 to A3, which is the production of the material and disposal of the material. All right? Now, like this, and look at the GWP over here. Now, this one doesn't come with a total, okay? It only measures A1, A2, A3. So from here, we need to add up all these together to get the final GWP that we're comparing. Got it? You got the concept already? More or less? Right. Then the next one is gypsum board. Okay, now this is interesting. Let's look at this. Now this one consists of several types of board, right? And this one is produced in Thailand, supplying to Malaysia and Singapore, right? Let's look at this. The same thing, you always see this table everywhere. The moment you look at EPD, look for this table straight away. It says here that it is a cradle-to-grave assessment, so it goes through the entire process, A, B, C, D, right? Now, from the raw material and transportation to the plant, global. The material comes from everywhere across the world. It is produced in Thailand, manufacturing in Thailand. Transport coming through Thailand, Malaysia, and Singapore, and the product is supplied and adopted in Malaysia and Singapore. A bit different from the other two just now, isn't it? Okay, so this is the data that we're looking at, and this is the manufacturing process of the boards, and this is the data. Right, looking at here, they combine A1 and A3 together, and then you get the GWP total in this area. Right, now whether or not a fair comparison, first thing first, look at this table as well, before we jump straight into this data. Making sure that the unit that we're comparing is the same, whether it's a kg, or a ton, or a square meter kind of a unit. All right, this is the total comparison. A1 and A3 taking up more than half of it, then followed by the transportation to project site, and then the rest. This is how it looks like, the bar chart, contribution of each section of the life cycle. Right? So, knowing all that, how do we do and what are we going to do about it before we wrap up the session? Okay, now, same thing, the cost of change is critical. All this needs to start early during the project LCA stage. The later we go, the cost of change will become higher and higher. So it is a good idea to start this at the early stage of the design. Okay? Now, this is a recap of what we have just now. The green color one is the embodied carbon, okay, covering here. And the blue color one is the whole life carbon, including the operational part of it. Okay, now, first concept and first idea, we look at the service life and replacement rates. According to some study, look at the screen over here, this is the life cycle of certain products, from the fit-out furnitures, 3 to 30 years, mechanical, electrical plumbing services, 5 to 50 years, envelope, cladding, fenestration, up to 75 years, structural foundation columns, 300 years, and the rest. Right? Looking at taking this into account, what should we do? Looking at this simulation over here, on the year 0, when we construct the building, this is the composition of the carbon. Structure take up this much, skin, services, and spaces. In a short term, year 5, you buy new furniture, additional carbon. And you remodel the kitchen again, more carbon. Replace your windows, some renovation again, more carbon. And after that, you do some extension of your unit, you incur more carbon. So, but the cooling and the power used in operating, this is the operating carbon, remains stagnant. So how much is the total carbon of your building? It depends not just on the operational, but also something above over here. So think about it when and what to choose for your design. Okay? The approach is build less, build intelligently, and build for the future. Okay, how? Build less. There are some studies that shows that retain and retrofit incur lesser embodied carbon. Obviously, right? Okay, compared to a demolition and new build. Okay, for a lifespan of 60 years, if you retain and retrofit, the ultimate carbon use is much lesser compared to you building a new one. Okay? Build less. Now, this is where you think and choose using the EPD. This is publicly available EPD. And normally, they will publish the service life over here. Let's just take one example. If you are taking a building with 60-year service life, okay, and for example, you're looking at a carpet tiles, Okay, and your carpet tiles, the first choice is that you have a 15-year service life. The second choice you have is 25-year service life. Within the lifespan of 60 years, you need 3 replacement cycles. But the other one, 25-year service life, you only need 2 replacement cycles. And every replacement cycle incur carbon along the way. So depending on how much carbon are you looking at, so something to think about, what to choose, and what are you planning for the long term in that way. This is how you use EPD to make your design better. Next, this is recycled content of a steel bar. More on the structure guy. So if you talk to your CNS, they can know about this. Recycled content of 0%, 60%, and 97%. All these are also published EPD you can find hosted on the program operator. Right? Now look at the box over here. Right? Now, GWP, this one is saying that it is 2.29 kg CO2 equivalent when it comes with 0% recycled content. But when you have a 60% recycled content, it gives you 1.26 kg, which is lesser than this. Right? When you have a high recycled content of a rebar, right, you get 0.62 kg only. So the embodied carbon for this material is far lesser compared to this, simply because it has got a higher recycled content. If I can allow me to go back, the recycled content contributes to this section of it. This section will put it back into here. So it will offset this value, it will offset the high value from here, and that gives you a good figure of your global warming potential over here. All right? You got the gist of it? So, of course, build intelligently. We're also looking at how to build safe. Okay? Make sure that the products are safe, far from heavy metal or carcinogenic materials. Recommended to have a red list free products, okay, along the way. This is some other examples, okay, built intelligently. This is choosing of floor tiles, okay, flooring systems. So when in the event of choosing what you want, right, first thing first is that maximize durability and specified products with take-back programs. Any exchange program available. How durable is your product? Is there any certificate that comes along with it? And of course, prefer natural materials made from wood stuff and all that. If you notice just now, you have the GWP biogenic. Any use of wood product, it will score an offset value if you use a wood product, because the wood gives a negative CO2 contribution. Other examples like this, where I look at the GWP over here, all these, the red color ones are the GWP. When you are presented with data like this, you can pick and choose to suit your design. You may not necessarily choose the lowest one, but at least you know where you are. All right? Of course, toxic exposure had to be taken care of. Not just that it is low in GWP, but it has to be safe, okay, from the manufacturing, installation, indoor air quality, away from hazardous waste, heavy metal, and stuff like that. And also human health implication, like what I mentioned just now. Right, so now, to sum it up, the key questions to look at when in designing, using EPD. First thing first, build less. Is really a new build necessary? Or can we retrofit for future needs? Can we repurpose again of an existing building on site? Or can the structure or system serve multiple purpose? Okay, the finishing surface, for example. Build intelligently. Can we rationalize the overall structure to avoid transfer structure, cantilevers, transfer beams, and all that? Reduce the use of concrete. Right? Can we reduce weight and dead load on the facade? Can we source material locally? Of course, we're only near. reduce carbon? Can we set project goals and selection criteria for material specification? And lastly, build for the future. Do we create allowances for future modification, retrofit? Does it have to be thrown away and build a new one every time? Or are we giving materials conditions that they need to last? You can choose a very durable product, but if your condition does not cater for it, then it doesn't mean anything, isn't it? How can we select durable products to limit replacement cycles and enable cost savings and mitigate environmental impacts? And lastly, how can we select finishes that are easily recoverable for use, for reuse and recycling? A lot of recycling, reuse wording appeared over here, but in the end of the day, it all depends on how we choose the product and what we want to do with it. The key takeaways is that there are many factors to consider when making material finish selections. EPD is one of the one of the main tool that you can use in order to help you to do that. Products, there are many products out there. Okay, they have wide-ranging environmental impacts. So choose wisely and choose carefully. Understand the product cycle, right? And of course, early goal setting is important to reduce the cost implication. And lastly, ensure all the EPD, all the justification study that you have is backed by technical documentation and certification programs. Begin with an end in mind, and that's how we achieve our goal. Right, so with that, thank you very much.
Okay, thank you, Mr. Brian, for the great sharing sessions. Okay, I believe you all have a lot of burning questions, so keep your questions to the Q&A sessions. Just now we saw that Brian have presented there is quite a number of takeaways, like I think there's 5 numbers of it, and I think maybe he missed out one of it. Is from one of the slides is actually show on the global warming. Okay. So when the time that we're going to have our tea break later on, so you don't be afraid that eat more, okay, because it's not that you cannot fit it into the clothes. It's actually because of the global warming. Okay, before that, we would like to make an announcement on the Craft 2020 event, okay, which is going to take place in this afternoon, 2 p.m. It's a World Architectural Celebration, Vibes KL, painting performance by Dr. Jalani Abu Hassan. It will start at 2 p.m., 2:30 p.m. If you're interested, you can just stay back and attend the event. Okay, without further delay, now it's like close to 10:30. We'll take a 30 minutes break, and please to be advised that the refreshment is actually served in at level 1 and level ground floor. And please get back to the hall by 11 a.m. Thank you. Architecture from Deakin University. He was a council member and served in the practice, disciplinary, building, statutory, and legislation, and CPT committees. He was also the past honorary secretary and also the vice president of PAM. Siong has been active in studying and working on fire safety from an architectural perspective. He has also contributed to the drafting of the current UBBL, as well as the publication of the Guide for Fire Protection in Malaysia. Architect Siong will be presenting the principle of designing for fire safety, the revision in the UBBL 2021 Part 2. Without further ado, please welcome Architect Chong Siong. The floor is yours.
All right, thank you. Thank you. Good morning. Okay. The title of the paper was supposed to be part 2 of the going through all the amendments of the UBBL 2021, but that would actually take about 3 to 4 hours if I'm trying to do the full part. So today, because we've got the privilege of having KNAF being our sponsor for this seminar, and KNAF, they are doing what dry walls, right? Good. So I thought, fantastic. Why don't I just focus today on all the elements of the revisions of the UBBL 2021 related to, okay, not particularly to dry walls, but it's related to everything and anything related to fire-rated walls, right? And then if it's one very old but still current, a Bomba circular that was issued in the year 2012, that particularly talks about the application of dry walls being used as fire walls. Right, so that circular is still active. We have gone through that with Bomba quite a few times in the process of when we were writing the UBBL 2021, and we sort of understood what Bomba wanted to do, and so we just kept that. Okay, I'll just go straight into it first. Now, as usual, we will need to set ourselves again a bit of just a confirmation or a reminder as to what exactly is the Uniform Building Bylaws. Now, we've always been, I suppose, like in practice, the document that we have on hand for us to do as a reference for us to design our buildings has always been the Uniform Building Bylaws. Now, the Uniform Building Bylaw is not a design guide. It is not even a technical specification. A Uniform Building Bylaw is a law. It is like you really cannot learn how to drive if you just read the Undang-Undang Jalan Raya, right? You read it, you fully remember all the things in the Undang-Undang, and then you say, okay, I'm now able to drive. No way, you can't drive, right? Because if you follow the Undang-Undang, you go on the highway, say 100 kilometers an hour, speed limit, boom, you drive exactly 100 kilometers an hour straight, constant, no deceleration, no acceleration, go around the corner also 100 kilometers an hour. It's not possible, right? So the Uniform Building Bylaw is actually exactly just that. It is not meant to be a document. Not meant to be a document for us to get our design inspiration from. We just cannot do that, huh? So the Uniform Building Bylaw is actually a prescriptive building code. What it does is that the compliance with this code is mandatory. It's statutory because it's a law. Whenever you sign on the building plan, you know what you're signing on. Saya mengakui that it's done in accordance with the building bylaws. So the compliance with this code is a statutory requirement. It is the law. It is something that we have to do. As the architect, we are taking full responsibility to be able to declare that the building is designed in full compliance with the building codes. And the prescriptions are just numbers. They're just absolute numbers. Yes, you can do this. No, you cannot do that. As simple as that. Whenever there are dimensions given, you usually be like, you cannot do anything smaller than that dimension. Like, for example, minimum room sizes. You cannot do a room size, a habitable room size, first room size. You cannot do it less than, what was it, 10 square meters or something? Or you cannot do anything bigger than that. This fire compartment for this purpose group shall be 5,000 cubic meters. That's it. It's so specific. If you do it at 5,001 cubic meters, you've broken the law. Sorry, things like that. Or you can say it shall not be shorter than this, or no longer than that. Or most often, it actually gives you a range. You cannot do anything smaller than this, but you cannot do anything bigger than that. It's like, that is really what the bylaw is, really. So it is just so important for us to actually understand why it's written in that way, because everything in between these thresholds that is being put into the law, we do have to understand fully what is the reason we do it, why are these numbers chosen. These numbers are not random numbers. When we say 7,000 cubic meters, is why 7,000? Why didn't we write 6,572 square meters? Things like that. Okay, but these numbers are they're all based on a lot of studies prior to this. Now, as we know, the our first uniform building bylaws is gazetted in 1984, right? And that one was led by our very honorable, the late Datuk architect Kington Lu. He was the one who was really championing for the development of the uniform building bylaws, and it was gazetted in 1984. So when I first came back to practice in 1990, to my surprise, the uniform building bylaws was only 6 years old at that time, because it was only gazetted in 1984. I was practicing in Australia for a few years before I came back, and over there we are using the Victorian building regulations, the Australian standards, and all these things. And all these things, I trace back the dates are the 1920s, 1930s, 1940s. And then I came back to Malaysia, I say uniform building bylaw, 1984. Wow, it's only 6 years old. But a lot of the things were adopted and adapted from the collection of the old British ordinances. If you all would have remembered, if you've actually read the building bylaws before you go to sleep, as a nighttime reading, you will find that there are sections that also involves prescriptions on how you construct fireplaces. Yeah, I say in Malaysia, why would our bylaws have a section that prescribes how do I build a fireplace? Yeah, Cameron Highlands, you see. So the British, under the British, for highland areas, they do have the British ordinances. Of course, they adopted it direct from Britain. So that's the history of our uniform building bylaws. And when I came back, I first got involved in the building legislation around about 1993, 1994. And that was a time that Mahathir, we are out of recession at that time. We had a very, very bad recession in the year 86, 87. We had a very, very bad recession. Then came the early 1990s. We were on track to the new Malaysia Baru. Okay, we had Dr. Mahathir Mohamad leading the country at that time, and mega projects already in the pipeline. We got KLCC, we got KLIA, we got the National Sports Complex, all these things. So we figured at that time, or rather Bomba and particularly Bomba, we figured at that time our uniform building bylaws, 1984, could not cope with developments like the KLCC. You cannot cope with developments like the KLIA. Because if you look at just our compartment limits, limits of compartment for fire zones, 7,000 cubic meters. What is the volume of the KLIA? Yeah, just one small hall is already exceeding that. So we find that a lot of the things we cannot cope. So to fast track the building legislations, immediately we had to look overseas. We looked at NFPA, we looked at European standards, we looked at Australian standards, we even looked across the border at SCDF, Singapore. What are those guys doing? Of course, Singapore, they already have a lot of high rises, they already got a lot of very large public buildings. So yes, we would not admit it, but yeah, we did look across to Singapore and we did borrow a lot of learnings from them to do that. So that did not culminate into a revised UBBL. What they did was we had a lot of special learnings, and there were a lot of special committees in the reviews and the approvals of KLIA and all these mega projects at that time. Yeah. Then of course, then we went through another recession in 97, 98. So that put a stop to all our efforts. and then when we came back, then there was renewed interest. There is, okay, it's time. We've already built all the mega projects. We have learned so much already. It is time we start to actively pursue the review of the uniform building bylaws. Because by that time, 1984 to after the recession, okay, it's more than 10 years already. So coming up to 20 years, so we say, okay, it is about time. So by December 2012, that's where the amendment, the UBBL amendment 2012 was gazetted. And we all know that the uniform building bylaws are the custodian of the uniform building bylaws are actually supposed to be the local authorities. right? And we know, I think all of us have experienced that, hey, hang on a sec, now that we have gazetted the UBBL 2012, why is it that certain states are not recognizing it? And worse, you go to the local bomba, the bomba state, we are now in Kelantan. Kelantan, we don't know what is UBBL 2012. So a lot of confusion, right? I think we all suffered through all that. We tried our very best. Bomba tried their very best to have all these road shows, all these seminars, and we tried our very best over here also. Yeah, with so many years of CPDs talking about UBBL 2012 and all that. But yeah, on the ground, we fully recognize we got a lot of problems because there are just so many parties involved, and really, we are really trying to just find our own way in a lot of situations. So, having recognized that also, fast forward to just a few years ago, we said, again, we came back around and Bomba said, come on guys, we must grab the bull by the horns and really, really push it through. And of course, a lot of situations have also occurred. There was a famous Grenfell Tower fire that we all know about, the really, really very tragic fire in London, and a few other situations, and a lot of local problems in terms of enforcement. Malaysia started the full industrialization again after the recession. A lot of new factories are being built. A lot of multinational people are coming in here, and they're bringing over a lot of foreign standards because these multinationals, when they come to Malaysia, they would want to first comply with local codes. Secondly, they need to comply with their own codes because all these multinationals, they do have to comply with the codes dictated by the entire supply chain. Right, you say you're a company, you're manufacturing a product that you're selling to, say, Apple. Apple is an international company. They are manufacturing right around the world. They require that level of standard in terms of robustness on the supply chain. Safety is of paramount importance. Yeah, they cannot afford any segment of that make up the entire supply chain to suffer a problem. If one plant in the particular world is supplying to Apple, if it burns down, you got a production stoppage for 6 months. Apple is dead. Yeah, they're gone. So the entire supply chain is governed under their own insurances, their own standards. So when all these people come into Malaysia, Malaysia is a nice, friendly country. We are neutral. We got lots of land. We used to have cheap labor, but no more. Yeah, but what's most important is that Malaysia, we speak all the languages. So the foreigners really love the country. So when they come over here, they find, your local standards are kind of low, not a problem, because their own standards are so much higher. Right? So we learn a lot from them to figure out, that is really the direction we should head to. So together with Bomba and all that, we eventually now, we've got UBBL 2021. So from 2001 to 2021, it's only 9 years. I remember the first one, it took us 28 years. 1984 to 2012 was 28 years. So now in 9 years, we have compiled the new UBBL 2021. And this time, Bomba is absolutely gung-ho. They said, okay, no more waiting for the local authorities to do the individual gazette. As of, is it April or February this year? They issued the, I think it's April. Bomba issued a directive already. I think 1st of April. This year, 2024. That as far as Bomba is concerned, when you submit plans, irrespective of which state you're in, as far as Bomba is concerned, they'll be looking at UBBL 2021. So UBBL 2021 is now officially gazetted, gazette is not the right word to use, yeah, but it's officially being implemented. And Bomba is using their powers under the Fire Services Act, yeah, on the directive from the Director General of Bomba. Okay, so guys, that one at least give some clarity now. So whatever we do, as long as it touches Bomba, on any matters that Bomba has got a say on, we are now to refer to UBBL 2021. Good. Okay, at least we have progressed a little bit. Now, so coming back to UBBL 2021. Okay, so today I will not go through the entire, all the amendments and all that. I will just focus on one element. But before we do that, it's always good to remind ourselves then. Now coming back to the basics technicality, okay? What is the concept of fire safety? Let's just remind ourselves. It is evacuation, most important, passive containment, active intervention, and access of firefighting and rescue. And how the UBBL governs all of these things, as we all know now, let's just remind ourselves again. When it comes to evacuation, passive containment, and active intervention, they are all specific prescriptions with very specific references to the purpose group of the building that you're designing, by the occupancy, the type, the size and height of the building, and very, very specifically referring to the UBBL schedules 5, 6, 7, 8, 9, and 10. Right, for all matters related to evacuation, passive containment, and active intervention. For elements related to access for firefighting and rescue, they are independent of the purpose group. You'll only be referring to prescriptions referring to the building height and volume for all buildings, with the exception of single residential buildings, with the exception of purpose group 1. So that is the way you use the bylaws. So a lot of times when we read the clauses, you find that, hey, I thought this is quite contradictory. On one hand, when you read something, you say, hey, you know, I'm supposed to do this, and then you read another clause, it seems to be saying something a little bit different. But you have to read it in totality. That's why I said the UBBL is actually a very, very good book. You should read it from page to page, but do it only when you can't fall asleep at night. Yeah, so it's, it's very good. The last thing you read when you fall asleep, okay, it gets locked into your hard disk for retrieval later. Right, so, and this is the basic concept that we must just always remind ourselves when we're designing. Sometimes when you approach bomber officers, when we all have experienced that. We draw up something, we go to bomber, and I suppose the first mistake we make is that when we go to bomber, we go on the basis that we are asking bomber, hey bomber, ini boleh approve ka? Or bomber, can I do this? Or bomber, how do I do this? That is probably the first mistake, because the moment you approach yourself that way, bomber says, ini orang tak tahu dia buat apa. Okay, this is the time they come up and they practice their they practice their authority on you. So let's always remind ourselves when we design, particularly for safe evacuation, the criteria, the parameter for designing for safe evacuation is that only one fire will occur in one location at one time. That means we do not design for a risk greater than that. It is just not possible, because if you say, oh, what if I got a fire here, so I plan my exit over there, then another fire happen over there, how? Then I say, if that's the case, why don't you just assume the whole building burns simultaneously, boom, everything explodes, So we always must remember that every design must have a set of parameters, right? And as far as the UBBL is concerned on fire safety, it is we assume only one fire will occur. In the worst case scenario, it is designing for the risk of one fire occurring at the one location at one time. Then the purpose of compartmentation is to contain that one fire that you are designing for, that will occur at that position. You are to contain that one fire within that one location at all times, right? This would be the base principle in designing for fire safety. You can't do more than this, unless you're designing a very, very specific building where it will be a client's requirement. For example, I was just mentioning the multinational companies and all that. They've got their own set of parameters, their own criteria as to what are the risks that you have to design for. They're way, way, way over and beyond the UBBL. Right? So the UBBL is just this. We have to just accept this. If you're designing for the US Embassy, you wouldn't be designing for this. You'd be designing for, okay, what if there's a concentrated attack, terrorist attack on the embassy, the missiles flying from above? lorry bomb coming in from the front, infiltrators already planted the bombs inside the building. Yeah, if you're designing for the American embassy, that's what you have to do, right? So, but in all other buildings, Malaysia, a very safe country, this is what we go for, one fire at one location at one time. Okay, so today we are going to talk about very, very, very dry, literally a very, very dry topic now, fire-rated walls in the UBBL 2021. Particularly in the UBBL, these are the specific definitions, the specific terms that are in the UBBL with a very specific definition. So there's 6 of them: party wall, separating wall, compartment wall, external wall, protecting structures. We're referring to the walls that are that's forming the protecting structure. Yeah, and then partitions. We are referring to where the partitions require to be fire rated. All right, so there's 6 of these elements. Okay, let's dig into it. So, party wall. The definition on party wall, which is in bylaw 2 under the interpretations, is that a party wall means a wall forming part of a building. Now, okay, none of these are my own writing. These are all verbatim from the UBBL. This particular seminar, I suppose, was a bit easier on myself because I didn't have to write anything. I just photocopied. So all these are verbatim. These are the exact phrases. Pardon spelling errors and slight grammatical errors here and there. Because this is another story I'll tell you. I hope it's not recorded. When we drafted all of these things, because it's a law, you have to go through the Attorney General chambers. That means the government's lawyers have to run through it and they have to edit it, and they seek audience with us also because they will try to understand it. This is a law, you see. So the document actually has to comply with what a law document says. You have to have legal speak, lawyers type of languages in the sense. So what we discovered is that since the drafting of UBBL 2012 and also 2021, in our rush, of course, we are doing all the editing and all the typing. Sometimes we got typo errors, and I said, never mind, I said, AG Chamber Show will pick it up. Sometimes they don't, So to our surprise, when we get back the document, gazetted already, all our typo errors are in there. So please forgive. Please forgive. If you spot anything, let us know. Yeah, we will try and amend it later. Okay, so party wall means a wall forming part of the wall. But the key word here is that party wall is a wall separating adjoining buildings. And secondly, belonging to different owners. And then by inference, actually this is expressed also, all occupied by maybe a different tenant. But I think the primary keyword here is different owners. All constructed or adapted to be occupied by different persons, all constructed over or abutting a common boundary. You see? So a party wall here is a legal definition. It is a wall, first physically separating adjoining buildings, but more importantly, for it to be called a party wall, is that it's actually separating different ownership or different legal tenancies. Right? And the actual clause on party wall is in bylaw 86, and bylaw 86 is in part 5 of the UBBL. It's not in part 6 or parts. It's not in parts 7 and parts 8. It's in the constructional requirements of a building. So all party walls shall generally be not less than 200 millimeters total thickness. And it specifies solid masonry, or now this is where we inserted the additional thing, right? Originally it was just solid masonry or constructed of masonry blocks and all that, and now we said or constructed of other materials of various thickness. We are not specifying anything. All right, we are just saying that as a party wall, first, that's a 200 millimeter total thickness minimum 200 millimeter. of solid masonry. That means we are expecting that the wall is to be something solid, right? Or it can be constructed of various thickness, materials of various thicknesses. That means it means that you can actually laminate the wall. There can be a series of materials that you make up to construct the wall. But the key element here is it has to be solid, something at least 200 millimeters. Then the third item is you must have an acoustic performance of at least STC 50. Right, so here it implies that as a party wall, you're actually separating two different owners or two different distinct occupancies. So, of course, the first thing is you must have visual privacy. We never said anything here that you cannot use a glass wall, but it is assumed that you must have a visual privacy. Right? Then secondly, we actually prescribing a physical thickness. Right? Now in UBBL 2012, clause 86 was actually removed. Don't know if you noticed, yeah, in UBBL 20, clause 86 was actually removed. So I came up with a scenario that if one day we can produce a material that can give a 2-hour fire rating, absolutely solid, integrity, insulation, stability of 5 millimeters, a piece of maybe a plastic material or whatever, non-combustible, 2-hour fire rating, just 5 millimeters. I'm going to stretch it from roof down to the floor, and that becomes your party wall. Would you accept it? People say, everyone was horrified. I said, that's exactly what happens. You remove a clause 86 that removes the physical properties you will expect of a party wall. Right? So, okay, so this is it. So we put it back in here. So it must have acoustic performance. Then, now let's read a little bit further. If the party wall is to be made of 2 different times, okay, it shall be made of 2 separate skins. Each skin shall not be less than 100 millimeters thickness, constructed at different times. So that means there can be a situation also where your party wall is actually only 100 millimeters. Right? If your neighbor have not constructed it, you're only constructing your own wall first. Right? Then, multi-story residential buildings or reinforced concrete or other frame construction. In other words, integrated construction, when you're building the thing at one time for multi-story buildings. The party wall thereof shall not be less than 100 millimeters total thickness at any point in the wall. Then again, item clause 4, subclause 4, no combustible material shall be built into the thickness of any party wall unless not less than 100 millimeters of masonry or a fire stop or the equivalent fire resistance material of the equivalent fire resistance period is provided between such a material. Okay, so in summary, the key takeaway is to the party wall is, first, there must be at least 100 millimeters thick of a material that is totally non-combustible, that is solid in nature. And by that, we infer it should be something stable, it should be something of a certain integrity, that it can stand up, and it shall then also provide you with an acoustic rating of STC 50. Right? Now, the last 2 things. Openings may be made or left in a party wall, provided the written consent of owners of property concerned are obtained in accordance with these bylaws. And every opening in a party wall shall be reinstated if this requirement is no longer needed. Yeah? So here you see, it doesn't say that you're allowed to have a water pipe crossing from your building to the adjoining building. It doesn't allow, or doesn't say that you're allowed to have a ventilation duct going from your building to the adjacent building, because it says nothing about fire stops over here. Right? But it says that should the 2 owners or the 2 occupiers of the 2 adjoining lots agree, they get married and they become one family, right? They can then remove the party wall. See, by doing an opening. Right? It says opening. It doesn't say, I mean, if I remove my requirement of the connection is entirety, I can actually remove the party wall, provided the consent is given. Right? So here the takeaway is this. A party wall is a legal definition. Its purpose is to provide privacy in terms of course, visual privacy, acoustic privacy, but most important, as far as we are concerned, that 100 millimeter thickness of a material, a solid material. Okay, full stop. Okay, that is the physical legal requirement of a party wall. And if you do not need that party wall anymore, good, you can just open it up. Right? But if you want to sell off the lot separately again, if you divorce after that, you want to put the wall back, yes, then you have to put the wall back, party wall. Okay, good, too. Now, separating wall. Okay, so you got a party wall. So what's the purpose of a party wall? A party wall is to separate two adjoining buildings. So here now we got a new definition called separating wall. This is in bylaw 133 interpretations, which means that it is well within the part 7 and part 8 already of the UBBL. All right, so let's look at that thing. A complete vertical wall separating any buildings, which is practically like a party wall in that sense. And now this is where the differences start to come in. It doesn't prohibit the passage through a separating wall of pipes, flues, and then later on it also talks about it does allow ducting and anything to go through this wall, right? Provided that all the crossings will have to be fire stopped when it passes through the wall. And any separating wall which forms a junction with the roof, etc., will then have to be carried 225 above the roof. In other words, what the separating wall does is that it defines the fire rating. Right? This is now a wall that is required to be fire rated. A party wall, it doesn't say that it needs fire rating. Right? The party wall just describes what are the physical properties of the wall with regardless to its solidness, its minimum thickness, and the acoustic properties. Now, if that party wall is functioning as a separating wall, it shall now require fire rating. And then if you permit any utilities and all that to go through, you will then need to fire stop it. And if you build a wall, if you build a doorway through a separating wall, you will then have to install a fire rated door to the same rating as that wall. Whereas as a party wall, you say you want to open lah. Yeah, you don't have to reinstate it, because the moment you do that, it means that you no longer need the properties of the party wall. Right? But if it's a separating wall, that means that this is required as a separating wall for fire safety purposes, then this wall must always have its fire rating. And any openings and anything going through that, it must be protected with an element that has got the same fire rating. Okay, compartment wall. So a compartment wall and of course a compartment floor means respectively a wall and a floor which complies with bylaw 148, etc. And particularly a compartment wall is for the purposes of bylaw 136. We got separating wall already, fire rated, so what's a compartment wall? Okay, now look at a compartment wall. It's particularly for the purposes of bylaw 136. So what is bylaw 136? So it's any building other than a single building. Okay, talk about fifth schedule. Fifth schedule is definition of purpose group, right? Then from the fifth schedule, it starts to define maximum fire compartment limits. Limits of fire compartments by floor area and by building volume. So this is where compartment walls come in. If you build a building very, very big, but if it's of a purpose group that does have a limitation on the maximum volume or maximum floor areas, fire compartment that is, then the element that you use to break down that volume into within, so that the volume becomes within what is defined in the fifth schedule, those elements are known as compartments, fire compartments. So compartment walls' primary purpose is for this, to limit the size and volume of a fire compartment. Still on compartment floor. Specifically also for flats and maisonettes within an overall building, i.e. your apartments, your condominiums and all that. They say we do not have volume limits for residential buildings. Yeah, but it specifically say under bylaw 138 that if you're doing a flat or an apartment, each individual residential unit must be compartmented from each other. Okay, so first, the overriding definition for compartmentation is that you have to compartment things to keep all fire compartments within the prescribed limits in the 5th schedule. Then on top of that, for flats, individual residential units in a complex, every one of them must be compartmented irrespective of volume. Right? Then, any floor or any wall separating a part of a building from any part of the same building, which is intended for a different group or different purpose, right? You need compartment walls. Right? So you may not have exceeded the volumes, but it is of a different purpose group. Then you need to compartment up that purpose group from the rest of the occupancy of the same building. Okay, we are okay with that? Huh? So we've gone through 3 already. Party wall, separating wall, and compartment wall. So now we got this other thing known as external wall. We all say, what has external wall got to do with fire rating? It's actually true, external wall, actually there is a prescription for fire rating. Then you say, yeah, if like that, then my window how? If the building needs a 2-hour fire rating, my external wall is also require fire rating, then what, do I have to now start installing fire-rated windows? No. See, when it comes to external wall, okay, first the definition. External wall means an outer wall. Yeah, that's very simple. Notwithstanding that the wall may actually also be adjoining another building. Right? But let's look at external wall bylaw 142. Generally, the external wall, where the prescription of fire rating is, it is defined under the 6th schedule, limits of unprotected areas. 6th schedule, we'll have another 3-hour seminar for the 6th schedule. But generally, 6th schedule just means that if you have an external wall, your building will form a threat to anything in front of the building, any other building adjoining the building. Right? So there will be a certain limit of how close the adjoining building should be to you relative to how much unprotected areas on your external wall. So if your entire wall is a full glass wall or fully open, then your adjacent neighbors will probably have to be quite far away from you because you don't have a protected wall. Huh? But if you so decide to limit the distance, you want to reduce the unprotected areas, that means you want to reduce your window sizes so that the adjacent building can be much closer to you, then the element that you use to reduce the unprotected areas are then the protected areas. So the protected area is where the fire rating comes in. Right, so the application here is not that external walls need to be fire rated, but it's just that if you design it in a manner that you're declaring that the wall is actually a protected surface, then you shall apply the manner of construction. Okay, so when it comes to external wall, when you talk about the 6th schedule, protected areas, we will also be talking about the cladding. Okay, so this one is a very, very quick reference. Again, we do have a 3-hour seminar just on external cladding. So yeah, then we'll pick it up another day. Generally, what it means is that the any surfaces, if the building external wall is no higher than 18 meters, you will need a Class O specification on the wall surface, or anything that you intend to tag onto the wall, it shall be Class O. But if it's above 18 meters, then you will have to go for full-scale testing of the system on BS 8414. Okay, so this is quite simple. And of course, there's also horizontal and vertical flame barriers between the floors. Okay, good. Now we go on to element number 5, protecting structures. Let's look at the definitions. Protecting structure itself means any wall or floor or any other structure which encloses a protected shaft. Right? And then you say, what is a protected shaft? So then you also look at the definition of protected shaft. Protected shaft means a stairway, lift, escalator, or chute or duct, or any shaft that is penetrating between compartment floors. Right? On compartment floors, we do have another bylaw that defines where and how you need to do compartment floors. So a protected shaft is any shaft, anything that will be penetrating through compartment floors. Right? That will have to be protected. Which means that all your stairs, lift, cores, services, risers, anything that's going through compartment floors. Right, number 6, partitions. So partition means a non-load bearing wall of any internal wall, which is not a party wall, not a compartment wall, not a separating wall, and not an external wall. That means everything else lah. If that thing is not, if the wall is not functioning as a party wall, is not functioning as a compartment wall, is not functioning as a separating wall or external wall, then it's called a partition. Then you say, why am I having partitions in this fire safety seminar? Say some partitions will actually need to be fire rated. So you say, where in the world? You already said everything. Compartment wall pun is not a partition. Separating wall also talk about already. External wall also talk about. So why would there be partitions now that I require fire rating? Oh, okay, there it is. See, protected corridors. Now we look at protected corridors. Protected corridors means a corridor separated from the building itself by having partitions of having a certain fire resistance period. See? We still have not covered all the walls yet. So there are requirements for partitions to be fire rated. And protected lobbies means a lobby enclosing throughout by partitions having a certain fire resistance period of not less than half an hour. And these are only the definitions. So, okay, we quickly now jump into elements of structure. So what are the elements of structure? Just now we talked about fire rating. So all that we mentioned, not the party wall, the party wall gets its fire rating from the definition of a separating wall. So separating wall, compartment wall, and what's the other one? Lost already. Okay. Separating wall, compartment wall, then we've got the walls to protecting structures, and we got external walls which are not declared as unprotected areas. Yeah, that means external walls that form the protected areas. They shall then be referred to elements of structure, and wherever any items of the element of structure, you derive its fire rating from which schedule? Let me go to there. Okay, first we define the element of structure. So it is those A to H is how many items? Okay, it's those items A to H. Basically, any structural frame, except if that structure is only holding up the roof. Any floor, compartment floor. Okay, now we just want to look at walls. So any external wall, which is not an unprotected area, separating wall, which a party wall will fall under the terminology of a separating wall if you require fire rating, compartment walls, and structures enclosing protected shafts. So when we talk about walls, this is it. So partition is out of it, right? But partition gets its fire rating from the description of the bylaw or what it's supposed to do. And just now we talked about protected corridors and protected lobbies, right? Okay, there are some other exclusions as well. Now we go away from the definition of the wall now. Now we look at application. UBBL 139 specifically says the following areas, and this is a prescription, right? The following areas shall be separated from other areas of the occupancy, etc., etc., and it shall be of a fire resistance period according to the 9 schedule. So this is very, very specific. Now, none of these are, they may not necessarily be compartment walls. Why? Because you may not be actually compartmenting or limiting fire volumes. By definition, we're just talking about definition. They're not necessarily separating walls, are they? Because you're not exactly separating two different occupancies. They are not an external wall. Maybe they're not an external wall. Some parts of it may be part of an external wall. But really, here we're talking about these walls are really partitions because they don't fall under those specific classifications. But however, Bylaw 139 specifically prescribes if you have partitions forming these usage, partitions making up of these usage, then the walls must be constructed with the FRP according to the 9 schedule. Right, so it's A to H. It used to be A to F. For UBBL 2021, we've added G and we've added H. So a cold room here actually refers to the refrigeration rooms, the fridge and all that, because we have identified the cold room. We think that the cold room is cold. When you enter a cold room, open your refrigerator, you see all the condensation and all the icing in there. Saying this one, how to burn. But yeah, if you enter a commercial cold room, you'll find that it's actually extremely dry because it's so cold. All the moisture is taken out, and it's got ammonia because all the refrigerants are all running in there, and it's got a lot of, say, food packaging, food materials. So actually, cold rooms are extremely high-risk fires. If it actually does catches a fire, it's very, very difficult. So that's why cold rooms are particularly under this bylaw 139 now. Good. So after having gone through all that, now we look at fire resistance. Fire resistance means, unless otherwise specified, for partitions and all that, all elements of structure, you have to follow the 9 schedule. And the 9 schedule just goes by purpose groups, size and volume of your building or size and volume of your compartment, and then it gives you the prescription. And it applies to all elements of structure. If you've got 2 purpose groups adjoining each other, the higher prescription will take precedence. Right? That means that if you happen to have a separation wall between 2 purpose groups, the fire rating of the separation wall will then follow the higher prescription, whichever that is. Right, then you talk about fire resistance. So how do we determine the fire resistance of that element? How we do that? It says any element of structure, and when I say element of structure, we mean that 9 elements that we mentioned already, particularly the 4 walls that we mentioned, shall be constructed in accordance to the specifications given. Is back to the 9 schedule again. 9 schedule gives you the numbers, the rating, half hour all the way to 4 hours. But the 9 schedule is supported by a lot of other schedules with the specifications of different construction methods. And that's already embedded in the 9 schedule, giving you the notional period of fire resistance. So in the 9 schedule, if you use any of those elements constructed in the prescriptions in the 9 schedule, then you are deemed to comply with the notional period of fire resistance that is prescribed in the 9 schedule. Now, if you're using something that is not already prescribed in the 9 schedule, then how do you determine the fire resistance rating? Then you have to go for testing, right? And this is test of fire resistance by law 221. For the purposes of this part, requirements to the fire resistance shall be construed as meaning, etc., in accordance primarily to BS 476. So if you're testing the fire resistance period of structure, you go for part 20. If you're talking about the wall element, you're going to part 22. You're talking about flame resistance, the surface spread of flames. To achieve class O, you have to go for part 6 and part 7, etc., etc. Yeah, so there's all these tests related to BS 476. Now, in the industry, we do know that BS 476 is the very, very rudimentary test that was created long time ago. That a lot of our new requirements now may not be adequately captured by BS 476. The case in point is the external cladding. BS 476 cannot possibly cope with the kind of new tests and new scenarios now on wall cladding, which is why we've got BS 8414, BS 8414 specifically for cladding systems. Yeah, but in terms of material testing, BS 476 still applies when it comes to these references that we're talking about. Right? So the golden question now is party wall or separating wall or compartment wall? When we write our specification, do we write this one a party wall or separating wall or compartment wall? I don't really think that we have to actually write it that way. I think we just have to specify the construction. If Bombard asks, then you say, hey, you tahu UBBL ka, you know? All right. But the way it works is like this. All right, so construction requirements. Bylaw 86 will be party wall. And then fire safety installation requirements. That means how you specify it, how much extension above the roof you need, how do you fire stop the junctions, what are the elements that you have to fire stop, what limit of non-combustible pipe do you allow to go through a wall without any other fire stopping, etc., etc. You'll find all the prescriptions in the respective bylaws. But to summarize, to make it very, very simple, for example, a terrace house. A terrace house, there are no compartment limits to a single residential building, right? Doesn't apply, no compartment limits. So there are no compartments in a terrace house. Inside it will all be partitions only, and all the partitions, you don't have anything in your house that will be picked up by UBBL 139, is it? You're not going to have lithium ion storage, ESS room in your house, right? Nowadays, maybe you have. Okay, so a house, the only fire rating you talk about is that of the party wall. So you have to construct it as a party wall. That means you cannot allow any structures to go through. All your roof structures, everything must terminate. You cannot share your neighbor's water. You cannot have the neighbor's water pipe going through his house and distributing to your house. You cannot have the neighbor's, you cannot have the incoming electrical cables going from the end lot corner house going right through all the party walls to distribute it to your house. You cannot because a party wall is a party wall. It says you must have minimum 100 millimeter thickness of non-combustible solid material without any penetrations. And you have to then construct it as a separating wall. That means you have to ensure that the junctions with the external walls are fire stopped. And in the case of you going through the roof, you must have at least the 225 millimeter the parapet, right, as a fire barrier between the two adjacent roofs. Right, now that's how we apply. So for bomber, they should only be looking at the construction of a separating wall and respecting the solidity, that 100 millimeter thick solid material infill for a party wall. Okay, so because it's a party wall, separating wall allows you to have crossings of pipes, flues, ducts, and all that, and combustible material provided you fire stop it, right? But because it's a party wall, so the requirement of a party wall overrides what is permitted in a separating wall. Multi-story apartments, again the same thing. These are compartments. They are not separating wall anymore. Why? Because there is that, what clause is it again? The 1.3 something, that every single residential unit in a multi-story development must be compartmented from the adjacent areas. So these are compartment walls. So therefore, it is also a party wall because they are independent, they are individual units, individual owners, okay? So again, the same thing. It will be constructed as a party wall physically, and in terms of the fire rated integrity, you have to be constructed as a compartment wall. So again, party wall will override the compartment wall detailing of having penetrations and all that going through. Then another example. So then you say, what's the purpose of separating wall? Every time I do a separating wall, so you say I cannot do this, I cannot do that because it's a party wall, right? No. Separating walls do have its purpose, right? Like in the case of this thing, I say in a building like this is one single building. You'll probably be sharing all its fire safety, all its fire installations and all that. So if a building like this, what is the statutory height of this building? Or especially in relations to the specifications of for fire safety. Go back to my second or third slide. Under what criteria that will apply to which aspect of the concept of fire safety, where we look at one criteria which will apply to all purpose groups? We're talking about access for fire safety and rescue. Right, we're talking about perimeter fire appliance access way. Those things are by volume. We're talking about the provision of firefighting shafts, provision of risers. Those things are irrespective of purpose groups. Right, so your building height definition and the height to the topmost floor is very critical. So in a building like this, is there a pointer here? Okay, so in a building like this is one whole building. So if that is the building height, that's the height of the building, right? So this building height, obviously, you will require a full firefighting shaft. You will require the fire lift. You require probably a wet riser already with a height like this. So once you have a firefighting shaft, once you have the wet risers, there are also the coverage of where you locate the fire lifts, right? Okay, what is the radial coverage of the location of a fire lift? Pop question here. Kanav, are you giving out any free samples or free gifts? Never mind, pop question. Right? So, for example, fire lifts, right, you need a coverage of 60 meters. So, if in this situation, I have a risers is 45 meters. Right? So, you need fire lift, coverage 60 meters, and the riser itself is 45 meters only. So, if I have a building like this, and this is one single building, I put the, at this corner, I put the fireman's lift, I put the risers over there. I may find that I will not be able to cover this area. So I'll need a secondary riser on that side to cover this building, right? Because this is one whole building. Now, where a separation wall will come in is, if you build a separating wall, you still have all your services to be able to cross. You still have your pipes, your flues, your ducting that can cross, provided, of course, you have the fire dampers and you have the fire stops and all that. You can still cross accommodation crossing. You can still do that, but provided your shutter is fully fire rated and fully insulated and it comes down when it's required. Yeah? So those are all the things of the specifications of a separating wall. But by doing this vertical separation, you're now physically, from a fire design, from a fire safety concept design point of view, you're now physically able to separate the building into two. There's a building A, part A, and building B. And both of them can have the respective heights. So building A will of course, have to be built with the firefighting shaft, risers, and all that. Building B, if it's less than 18 meters and the topmost floor, good. You don't need a fireman's lift. You don't need a riser. And those provisions. This is a separating wall. But of course, if you do decide to break up the lot, subdivide it into two legal titles, sell it to two separate buildings, go ahead lah. You already got a separating wall, but not so quick. Why? Because your separating wall will these two buildings is designed at the same time by the same architect, isn't it? It's probably using the same fire systems. So you got all the sprinkler pipes and everything crossing the wall. But once you divide it into two separate ownership, that will have to be turned into a party wall. Turning into a party wall means what? I have to cut off all the services that's crossing the wall, right? Then you have to apply the construction of a party wall. So you have to break up everything. This building, you have to start reinstalling all your fire services again, all your water supply and electrical supply and everything, and turn that into a party wall, which is a physical separation of all the systems. Yeah? Okay, I hope I'll make that clear, yeah, in terms of the definition. Okay, good. So now we'll go to the elephant in the room. 17 February 2012, this is, yeah, it was just before we gazetted UBBL 2012. We gazetted it in December, but it was already, they were already talking with it already. They almost wanted to have this put into the UBBL. We said absolutely no way. Said the UBBL is purely a law, as I said. Yeah, just define the performance parameters. Don't go into prescriptions. But yeah, at that time Bomba is having a lot of problems. So this one, actually, this Arahan consists of three different issues. Primarily, the drywall issue. Then there's a hose reel installation issue, which we've sorted already. Hose reel installation, it took us 9 years. So 2021, we've sorted out the prescriptions of the hose reels already, how to do the installation. And then there was another element, so it doesn't matter. So particularly for drywall, now this thing occurred. Now, just recap. What is the purpose of a party wall? What is the purpose of a separating wall? And what's the purpose of a compartment wall? Just recap very quickly. Party wall, separating of parties. Full privacy, full separation, right? Party wall, that is. Separating wall, dividing buildings. Dividing buildings so that you can classify the volume and the height of a building separately if you have a separating wall, correct? Compartment wall, to be compartmenting limits of volumes that will dictate when you need sprinklers, where you need smoke spill systems, where you will need other provisions in terms of active systems in the 10 schedule. Right. So what has happened is that Bomba has been having a lot of problems with all these very large buildings, primarily buildings like warehouses, factories and all that. Very, very large volumes, multi-stories. There are compartment limits. When you reach that, what's the compartment limit of a warehouse? When you're above 28 meters, for example, it's only 1,000 square meters. It's ridiculous. Only 1,000 square meters. If you want to build such a high warehouse, in terms of number of floors, right? Same thing with factories. Yeah, what's the limit? Car parking, storage. What's the volume limit of storage? It's only 5,500 cubic meters. 5,500 cubic meters. You put in sprinklers, it's only 11,000 cubic meters. For a flatted factory, most times it's too small. So very creative architects, what they've done is that they've indicated all these compartment walls to limit the building. So they got this huge building, multi-story, huge floor plates, and they put in these drywall partitions. Fire rated law because Knauf gave us a certificate now. It's status to BS 476 part 22, 2-hour fire rating or 4-hour fire rating. So they did that. So that by that they complied with the compartment limits. Right? One giant warehouse and they got all these partitions. And they complied with the fire compartment limits. What happened after CCC? The walls are taken down. Huh? Right? So from a building that doesn't need, say, sprinklers or doesn't need smoke spill, you end up with a huge building that's 5 times the size of the compartment limit. So Bomba had a big problem. But of course, we always say those are enforcement issues. We designed the building right, we are the architects, we only do things correctly, we never cheat. Once we put a CCC, the building is designed according to the UBBL. If the owner decides to do something else, itu dia punya pasal lah. Say, no, we have to put a control to this. You cannot even allow owners this opportunity. Yeah, it's a long-standing thing. You know, I've been on this for 30 over years already. I'm sick and tired of it, but we do what we can. And Okay, this Arahan came from Bomba. It's not my job. Definitely, I'm not related to this at all. But the Arahan is still in force. And in fact, it got a bit worse because when it first came out, at least we understood what it is. But now after 10 years, 12 years now, a lot of the new Bomba officers that just graduated, they do not know the original intent of this Arahan. So yeah, we all face our problems. But I hope this one will make it a little bit clearer so that when we approach Bomba, we approach them with certain clarity. Don't fight it. We cannot fight it because they are the authority, right? But at least when we approach them, we will know what we are doing and we follow the intent. Kanaf and their fellow industry players, they are working very, very hard to address these issues. Okay, let's go straight back to this now. So this is the Arahan Ketua Pengarah Bilangan 2 2012. And again, this is verbatim. This CBD is very good. I didn't have to write anything. Okay, so this is verbatim. First one is a proscenium wall. I didn't talk about proscenium wall because it's just a one-off item. If you're designing a theater, you'll know what to do. So this one is specifically hard kegunaan, drywall construction, and partition system. Very, 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 very specific. And what is the limit of usage? Proscenium wall, never mind. We'll just go run past it. So first one is protecting structures. Now, we have already gone through the definition of protecting structures. We know exactly what it is, okay? Tidak dibenarkan. Okay, no question. Don't even fight it. Don't even bother arguing over the counter. It's literally just that. If you got a protecting structure, do not specify drywalls. Right? Just ignore it. For now, just don't specify it. Go back to conventional masonry construction. Dinding dua pihak party wall tidak dibenarkan. Okay, again I said don't fight it. It is so clear cut. Now, compartment walls, is it tidak dibenarkan kecuali untuk drywall jenis solid dan infill. Right, so the intention at that time, of course, when you talk about protecting structures, it is really the backbone of high-rise fire safety for Bomba. Right? So they do not want any situation where the construction of the wall is anything less than masonry or less than concrete. The impression is that if you use drywall construction, it can be very easily removed. It can be very easily damaged. And it's something very easy for people to do a modification. Right? And that would be taking away the integrity of the spine of firefighting and the spine of safety in terms of exit stairs and all that, right? But for compartment walls, they also recognize that, but they say, okay, let's have some leeway because compartment walls are not party walls. They are not separating wall per se. They are really compartment walls within your own arrangement, and you're using it for purposes of, you need a compartment wall, you will be varying it as your, say like a large warehouse again, in that typology, you may need to vary your tenancy requirements in a large warehouse. So what they're saying is that if you build a compartment wall and the compartment wall is such that it reaches the limit of the compartment volumes, then you'll have to come back and install whatever additional fire safety requirements and all that when you reach the limits of the threshold on the 10 schedule. Right? So they say to make it a little bit harder, but still allowing you to actually be able to have that future amendments or the future variations, they allow you to use drywall, but provided it's fully infill and solid. That means when it's built and when it's approved, the wall will have a better chance of it not being damaged or not being easily modified. That was the original intention. I know it sounds silly. Yeah, if you think about it now, it's like, what in the world is Bomba prescribing these things? You know, if my intent is to break down the wall, I'll break it down anytime. So But that was just how it developed at that time. Right? We won't want to fight it because it's a directive issue. No? We can't fight it. So same thing with a separating wall. Generally, it's not allowed except for solid and infill. And external wall, of course, go ahead, because external wall, we're only talking about unprotected areas and protected areas regards to the 6th schedule. And now we also got the all the new cladding requirements ready on Class O and BS 8414. Okay, so yeah, that's not the problem. Okay, now particularly for this is UBBL 139. Now just recap what was UBBL 139. Is specific high hazard rooms or high hazard purpose groups that you're going to have within another building. So this one here specifically it said tidak dibenarkan because they take this as a very, very high risk areas and it has to be like permanent install. That means if you as the architect, you say that is a high hazard store or that is the ESS, new energy saving storage, the energy storage system. Okay, no dry walls. Full stop. Sorry, Karen. All right. I think we also want to respect this. Just don't pick a fight. Okay, dinding store pejabat dinding bilik file. Okay, these are all the little storages within your own office. Bomba always say, even if you define the space under a stair as a store, they say, this one must be fire rated. We say, you must be kidding. I'm only going to put my broom inside under the stair. Say, no, must have fire rating. So now we don't even classify the area, isn't it? We don't say store di bawah tangga anymore, isn't it? We just leave it open. Tell the developer, save yourself the wall, save yourself the door. Don't even call it as a store. Owner want to build it, they can spend their own money to do it. So, but they also recognize that if you have a filing room and all that, because these things don't require fire rating, they need separation. But if it's within the purpose group of the office or we call it low risk storage, you're storing stationery and all that, okay, have a fire rated partition in there. Or a computer room, for example. You have a computer room. Most of times when we have computer rooms, we ourselves want to do the fire suppression systems. Right? So we will have to have fire rated. So Bomba said that is your own risk, your own requirements. Go ahead, use dry walls. There are no limits to that. And for hotel rooms, it's required. See, hotel room falls under that halfway between individual maisonettes in the building and the overall compartment volume of a commercial building. Right? Under purpose group 3, sorry, not commercial, it's other residential. So your hotel rooms are not necessarily going to reach anywhere the limit of compartment. But likewise, you do have to have some privacy between the hotel rooms, right? So Bomba is saying it's perfectly okay. You put the separating wall in the hotel rooms. It's not of a real concern to Bomba. Now you can break off the room, it becomes a 2-room key, triple the room size, as long as it's still within the overall compartment limits of other residential building. No concern to them. So okay, go ahead and use a drywall. Fire rated, of course, but you can use a drywall. Protected corridors. We talk about partitions, you see? Protected corridors. Good, of course you can use drywall, because this one falls under the same category as within the office. If you're defining an office, you're partitioning up the offices into different office cubicles, you're applying a protected corridor in your office. You only need a half-hour rating because there's a very, very specific prescription for how you do a protected corridor within an office space. Okay, so you are allowed. Just now there was a thing on the protected lobbies. You can have, say, lift lobbies and all that. You can use fire-rated drywalls, but particularly for firefighting access lobbies, no way. Okay, firefighting access lobbies is regarded as the same criteria as your firefighting shaft. So, protected structures, you cannot use drywall. So, likewise, firefighting access lobbies, you cannot use drywalls. The normal lift lobbies, yeah, they allow you to. use drywall. And data rooms, computer rooms, yeah, like I said, mentioned earlier, is within the same general risk in the office area. You may use drywalls. Operation theaters, particularly operation theaters in hospitals, you cannot use drywalls. Yeah, okay. Again, we won't want to challenge it. We'll just accept it. So, in summary, as we stand today, in relation to what Bomba is expecting from us, in accordance to the, I have to make this very, very clear. It's like legal speak already. In accordance to the directives of the Bilangan 2/2012, this is the application that Bomba will allow you to use drywall, solid or infill, or conventional drywalls, not classified as solid or infill. And of course, UBBL 9 schedule. All prescriptions in UBBL 9 schedule, you may use it for all of these elements. Then for drywalls and solid infill, up to separating walls, compartment walls. But bylaw 139 separations, out of bounds. Protecting structures, out of bounds. And party wall, out of bounds. And for drywalls, just drywalls, not classified as solid or infill. That's another story that maybe Knauf will be in a better position to tell as to how we classify something as solid and infill. Okay, I'll leave that to the experts. For just nominal drywalls, fire rated that is, partitions and external walls as a protected area, not as the unprotected area is allowed. Okay, everything else, okay, don't challenge Bomba, just avoid it for now. We hope that, okay, another just a news break now. Towards the end of the year, we should, between Bomba and PAM and our industry partners, we should be finally publishing the new rate book. All right. The actual date, actually, okay, I will not go into those stories yet. At the rate it's going, yes, we should be able to get it out already by the end of the year. It will be based entirely on the UBBL 2021 for obvious reasons. It will be fully updated. All the things that I've been saying over the last 10 years or so, hopefully a lot of it, okay, quite a lot of it has actually been incorporated already. As long as we have got this alignment with Bomba, it's already in already. Yeah. So the new guidebook will not talk about this because I see this as purely something quite topical, very, very specific on this element. Okay, these things will be overridden by directives that Bomba will be issuing from time to time, right? But the overall rate book would be covering the base of the UBBL 2021. Okay, so with that, thank you very much. I'll pass the mic back to Daniel.
Okay, thank you, Architect Siong, for your valuable sharing. We are now open the floor for question and answer. I would like to invite both our speakers to the stage. If you have any questions, please raise your hand and then our PO will hand over the mic to you.
Good morning. Morning. My name is James Chin, architect. I have a question for Architect Lee regarding party walls. This 200 millimeter requirement for the party wall, what is the logic? Because as you are saying, 100 millimeter basically fulfills most of the 2-hour rated fire requirements, etc. The other thing also is if you think of a terrace house construction, a brick wall being thickness of 110. So plastering, etc., solid masonry of 150. How are we going to achieve this 200 millimeters using a brick wall? Are you saying that they should not be using brick walls for terrace housing? What is the logic of a 200 millimeters?
The primary inference is actually from the very, very old British ordinance, where individual lots, landed properties may be built at different times. So the 100 millimeter minimum thickness is something that is meant for you. That means what they're saying is that if you're having a wall with your adjacent neighbor, you need minimum 100 millimeter of solidness between you and the neighbor. So if you have a situation where you're building the building separately, you will build your own 100 millimeter thick wall first. And the neighbor comes in, he builds his own part of the brick wall. And eventually, if you do decide to demolish your own building, you will demolish your half of the 100 millimeter thick wall, leaving the owner with his half of the 100 millimeter thick wall. It started from that. And it is still preserved in this manner. We did say multi-story buildings or buildings of frame construction, as long as you have you are allowed to have minimum 100 millimeters thick, provided you do not chase anything into that 100 millimeter thick wall. Yeah, so that is the inference. But the funny thing is this: Clause 86 is really to be under the jurisdiction of the local authority. Yeah, but Bomba has sort of taken over this thing, and there's a misconception then that because party walls need to be 200 millimeter thick of masonry, what is the fire rating of 200 millimeter thick masonry wall? In the, if you refer to the 9 schedule, it's actually 4 hours. So there was a time, which I think some authorities are still like that, they think that party walls need 4-hour fire rating. But if you refer to what is the fire rating required for individual house of that size, actually half hour. So you get a half-hour wall, the other guy get a half-hour wall. Collectively, may get a 1-hour fire rated wall now. So there's a lot of this is what happens. People do not understand what was the original intent. But as it stands, the practice is Bomba is just saying that if it's a party wall, if it's landed residential terrace house, just show them it's 200 mm thick masonry wall. That's the way it is at the moment. I can't comment any more than that already. So it's actually a full brick. You lay the brick the other way. Yeah. I know brick sizes have also been shrinking. That's why we actually came up with that 100 millimeter thick already, because we intend to go in that direction. But on the ground, Bomba is still saying, they're taking jurisdiction. Actually, we've been telling Bomba all this while that is not under your jurisdiction. Your jurisdiction is separating wall. Your jurisdiction is not party wall. So, but it's okay. There's another thing another battle to go on later after we sort out the bigger things.
Nick, another at the back there.
Hello. Mr. Chong, regarding the cladding system, the Bomba department have come up with the circular in year 2020, end of December, that some of the misunderstanding regarding the Bahasa and English from the circular by Bomba, issued by Bomba. That means Bomba stated that cladding shall be non-combustible material, but in Bahasa, they put it bahan tidak mudah terbakar. It's a different meaning.
Yes,
okay, we notice this we take this very seriously, and we notice every single word they wrote on the circular compared to the UBBL. So, one, we know that, and we check about the product in the market regarding the ACP panel. Most of the product, 99% in our market now is complying with the RF core, FR core, using FR core system. with compliant with the BOMBA requirement, and they have the test report and certificate from the BOMBA, comply to the BS 475 and also 8414 with different tested on the ACP panel. However, when we go to the UBBL and the page that they have a schedule regarding the cladding system and also the height of the building, I have two questions regarding this thing. First is for building more than 18-meter height. Okay, building itself more than, not the cladding, more than 18-meter height. The building more than 18-meter height, you are required to use non-combustible material for the cladding system. This means only one choice, a solid aluminum panel. Okay, but how about the building more than 18 meter, but the cladding installed on the facade itself is less than 18 meter? Let's say there's just a podium part, the podium less than 18 meter, maybe 60 meter. Is it we need to comply by using a non-combustible material as a category of A1 under the schedule? And second is the schedule stated inside the bylaw, the category of A2 and Class O for the cladding system, that one is not complied to the bylaw for the building 18 meter and above actually. So in our market and the building under construction around in Malaysia, actually for building 18 meter and above, they are using the FR core system, which is actually is not really comply lah, not comply lah. So I need to clarify us whether under bylaw building 18 meter and above, it mean the cladding who cover out until 18 meter, or if the building is 18 meter high, but the cladding system only cover out 18 meter below, can that cladding carrying to use the what we call the class A2 or class O material? This is, I think this is some gray area to me. However, in our job, we rejected all the FR system for building 18 meter above, even though the cladding system to install on the facade is lower than 18 meter. This is what I saw is like a gray area and need to clarification.
Louder. I'll try to use this. Okay, good, great. Okay, very, very good point that you raised. Yeah, and now I'll answer it two separately first. One is on the material. When we talk about Class O, we're actually talking about surface spread of flame actually in particular. Now Class O classification, okay, if I go into the technicalities of it, Class O classification will come from two BS 476 tests, parts 6 and parts 7. Right? Part 6 is on the combustibility of the material. Part 7 is on the surface flame or spread. I will talk about the limitations of British standard in another forum, but for now, that's what all we can referring to. So if the material has got a combustibility rating of less than a certain index from part 6, it's considered non-combustible. And if it gets a class 1 rating for the surface flame or spread under part 7, it's combine the two, you get class O. Right? So the classification for the use of the cladding on any building below 18 meters or any wall less than 2 meters away from the neighbor is either the material is non-combustible or it complies with class O specification. Where do you get the non-combustible? How are the materials defined at what materials are defined as non-combustible? You refer to the 9th schedule in the UBBL. Now, there are all the materials in there that says these materials shall be deemed non-combustible. Is it 9th schedule or? I think the 9th schedule, yeah, okay.
in the bylaw itself, okay, and immediately gypsum plaster is non-combustible. Any cement rendering is non-combustible. So that is already deemed to comply. Whereas if you don't fall under any of those classifications, okay, the manufacturer will have to at least get a testing, BS 476, Part 6 and Part 7, and combine it, and then we can rate it at Class 4. Okay, that's one. Now, so the bylaw also says now, any building above 18 meters, then the cladding system will have to go beyond just being non-combustible or Class O. In fact, you have to test it, BS 8474. Now, here, the keyword is buildings above 18 meters. It doesn't say cladding above 18 meters. So that's it. So if you're designing a building above 80 meters, you decide to put the cladding on any level, anywhere. Yeah, that cladding will have to comply with BS 8414. That is the way it works. Okay, when we're trying to draft these things, we did go through a few scenarios. They said, does it mean that if I have a tall building, anything above 80 meters, I use BS 8414, anything below, I use Class O, boleh tak? It's like saying, look, it doesn't matter, does it? Because if you have a building beyond 80 meters, if you do intend to clad it, you go for BS 8414, yeah, and that will then apply for the entire face of the building, if you do a non-combustible material, like say a tile, very popular in China, a ceramic tile stuck on the building, those tiles have got no cavity. So it's not a cladding system per se. Because it got no cavity, it's got no framing. It's just cement plastered or adhesive straight onto the surface. And if the tile is porcelain or clay, it is already, in the Malaysian context, it is already non-combustible. Then it's not a cladding system. Then under the non-combustibility criteria, you pass. Yeah. So the law had to be written in certain ways. The law will not be able to cover every single possible permutation. Yeah. But that's the definition. So if your building is more than 80 meters, okay, anything you intend to put on the building, you must get BS 8414. I hope that answers your question. Yeah. All right.
Any more questions from the floor? Or any questions to Mr. Brian? Nick?
The bracing of the structure is count as an element of structure?
Yes, it does. Because when they say element of structure, that means any element that is required for the structure to perform. So yeah, cross bracings will come. You come with that.
When we're talking about the fire protection. They say 4 hours, we use the board to do it. How to cover the bracing? Sometimes because bracing is very small.
If it is an element that contributes to the integrity of the structure, then yes. Okay, I'll give you. There's another example. You use bond deck for concrete floors, for example, right? Some bomba officers, overzealous ones will say, hey, you bring a bond deck, must put intermittent paint or you spray vermiculite. I say, you must be out of your mind. Right? They say, it is structure, ma? I say, no, it will form work. You see? So, is it form work or is it structure? Then you have to better let your engineer be aware, or you better know what your engineer is doing. If the engineer is actually specifying the bond deck with the very deep ribs, and he's including the rigidity of the rib as part of the reinforcement, or he's welding the BRC onto the ribs of the bond deck, then that is part of the structure. Right? Then you better fire rate it, because if the bond deck starts to deform, you'll bring down the entire structure. Right? But however, if the bond deck is being used purely as a formwork, all your reinforcements and even the thickness of the concrete does not include the thickness of the channels of the bond deck, right? Then it's non-structural. Then you don't have the fire rate now. So the question is this lah: what is the element of structure? If that bracing is absolutely required, or worse, if by the bracing deforming under heat, it actually pulls the structure inwards and causes it to collapse, then yeah, it has to be something that's fire rated. Yeah. I think you'll have to then check with the engineer. Yeah. When a question like this is very good that it actually arrives, because like I said, this is where prescription cannot cover everything. Same thing also, same thing with the definition of the height of the building. The prescription cannot cover everything. Yeah, but the intention is this, that structure for the shaft must be protected fully. So if there's anything that is added onto the element, and if that element can potentially contribute to the failure of the structure, or if the element is an essential part of the integrity of the structure, then you have to protect it. Yeah. So if the question arises, I'll say grab the engineer, let him sit down, and you grill the engineer. Yeah.
None of our Malaysia Standard Code or even UBBL give a division to FR core. So it become a gray area. How should we address that?
It's not gray. We actually do have standards. We do have standards for ACP already. Malaysian standard. You remember which number? I can't remember the numbers. We do. We do have a Malaysian standard already for ACP panels, specifying minimum classifications, minimum criteria for it to be classified in whether it's classified non-combustible or otherwise. So we do. And the same standards also governs the flatness of surface, allowable deviations for the purposes of recognizing the standard. So when a supplier comes to you, oh, my one is grade A, you will then understand grade A means you comply with a certain aesthetic standard, certain quality and all that. But having said that, that is the reason why we use the performance specifications. We do not prescribe anymore what is the composition of the core that we will allow to be used on the cladding. We just say it goes for performance testing. Surface flame spread doesn't involve the core. That's why Class O is a very, very dangerous thing when it comes to our specifications. And that's the reason why earlier on, there have been a lot of products that say, I've got Class O rating, but it's got the bituminous core inside. It's got that polymer core in there that's so flammable, because BS 476 Part 7 only tests the surface, flame spread on the surface. And when it goes for the Part 6, they only take the aluminum cube, they don't test the core. That's why for BS 8474 is a total system. It doesn't matter, we don't specify what you put into the system, but every system that you put in, it doesn't matter. You can combust, but for some reason, if you're able to meet the criteria of BS 8414, you pass law. Yeah. So that's the criteria. Yeah. BS 8414 are very comprehensive. It covers spread of the flames. It covers the temperature to control radiant fires. It controls the integrity of the structure. If the whole structure collapses, you fail the test straight away. Or even if falling debris, the things start to break off and start to fall down to the ground, we control the area in which the things will fall down. And the size, even the size and weight of the debris that comes down is being controlled. So it's quite comprehensive. Yeah. So we don't have to go into the prescription of the materials anymore. It is the overall system. Yeah. I will ask the question, is that link bridge part of your exit route? Okay, then don't worry. Yeah, then don't worry. Yeah. If you're the link bridge, yeah, just make sure that they can get off somewhere, jump off or whatever. Yeah. But don't worry, yeah. It's a bit like overhead pedestrian bridges. Yeah, you don't have to fire rate it. Yeah, it's an open structure. Huh? Yeah, that's the same question. Yeah, you'll have to separate the buildings. That means you need separating walls, or you need fire shutters and all that, and you have to respect 6 schedule, or make sure that you comply with 6 schedule. But the structure itself, if it is not a designated exit route, then no need. Yeah, but if you say, okay, half my occupants over here, they're going to go horizontally across this link bridge to the adjacent building, then you kena gao gao lah. You have to almost like make it bomb-proof. Yeah.
I think to that question as well, some link bridges that actually have cladding. So how to go about this?
Sorry?
Link bridges that use cladding.
Oh, good question. Oh my goodness. Technically, it's included, because you are adding another element to the screen, and LED screens, yeah, they contain a lot of polymers. They contain a lot of microchips. So I would think technically, yes, It's the same question that was raised some years ago on facade building signages. So we have all our buildings, we declared the unprotected areas already, then we declared non-combustible material, we declared class O. Then the next thing you know is all the commercial people come and put out the LED signboards, and usually the health and beauty parlors, they will have this giant fabric print of a nice lady wrapping up the entire building. So like, who is controlling that? It's a good question. It's a good question. It becomes, I would say for now, we got enough on our plate. So if you're not designing that particular structure, let the local authority gao dim lah. But if someone comes and asks you to design a structure like that, okay, maybe I would say apply our knowledge on building and say, you're actually putting a cladding. Technically, this is called a cladding onto the building. I will have to request for certain compliances. Yeah. Otherwise, I'll suggest you walk off because you're not in the position to be responsible for it. Yeah.
Okay, we are taking one last question.
Yes.
Okay. Thank you.
Thank you very much, speakers Brian, Wong, and Lee Siong. Excellent. I give you excellent for your all the way. My question is actually for Brian. I was really I think I appreciate all the slides for sustainability. I think you should compile it if you have, and I would love to have access to your charts from 1850 right after the heating. I'm not sure whether everyone here have been aware of the temperature change. I was just sitting with Fairuz just now. From the time, I think Lee Siong would know, from the time when we were young, right? So especially the Gen Z and the millennials, whatever you call them, they probably will know more aware. But I would love that if Brian Wong, if you can give us a link to all your information, you can be the presenter. I would love to have from your website, whatever, you give it to us. We would like to spread it around to all the chats that we have. And particularly if you translate that into Bahasa or Mandarin, that should be spread throughout Malaysia, because the awareness of the temperature change, I'm aware of Paris Agreement. I was part of it in 2015. But I'm saying, but the lay people do not know the implications and the ramifications of a temperature change to 2 degrees or 1.5 even. It's actually reached 1.5 at 2035. I think you all know that, right? So that's why Malaysia is accelerating. Every country is accelerating because the temperature of 2050 was supposed to be 2 degrees, but it's now reached at 2035. In most countries, most parts of the world, is 2035 will be 1.5 degrees increase. And what are the ramifications of the planktons in the oceans, and what's happening? We know because we are in the field. But a lot of lay people do not know that. And that basic graph, I think that will scare enough people because people like baby boomers are the main sinners committing all the carbon carbon footprints all over the world because they don't really care. But the generations that's in front of us, right, the Gen Zs and our grandchildren, whatever, they will not be able to see a lot of things that we now have. Polar bear is going to be extinct in 100 years, right? Because the Arctic is shrunk to 40%. You know that, right? So I would love, Brian, if you can give us access to what you have done. An excellent job you did, but presented for us that we can post to every forum and every chat group we have, who are lay people who would love to know your things, and especially the Malaysian, community in the kampongs. If you have that translated in Bahasa, pencemaran and all that, I think the older generation will also need to know. Yeah, really need to know. There should be a great movement. I think can't leave it on PM. Who's pushing for also the green thing. But really, you all don't the dangers of what we are facing. Right? I remember the time when we were doing the black hole. No, not black hole. Sorry, ozone hole. Yeah, which was repaired when we changed CFC to it was repaired generally to only about 10% now left. So I think it can be done. But what you have done is great. Thank you, Brian. You let us know what it is through PAM or something. Thank you.
Sure. Thank you for your feedback, and let us compile, and then we'll get back to you. Thank you.
Second question. Okay. Okay, quick one. Nick.
I have a question for Mr. Wong. Thank you for bringing us through this EPD, and we are all architects just trying to navigate through sustainability because it's a big term right now. Is there any a sign, sorry, it's a lazy question, is there a sign to say that this product has EPDs, or is there a way forward where every single material will have to have this EPD or not? Because the horror of trying to navigate and ask every single supplier, do you have an EPD? Do you have an EPD or not? And the best that they can offer me right now is, oh, we have low VOC, and that's not LEED recognized. So I'm just trying to gauge what is the way forward through this, because it's an initiative from everybody. Or is there a lazy solution where there is a signage to a star to say that, oh, I have an EPD? Sorry, it's a really lazy question. Thank you.
No, I think it's a valid question. I think it's important that it is a way or a sign that you can tell from the catalog or brochure or something, right? Unfortunately, I think right now there isn't any. There is no mandate from the government. And I was talking to architect Chong just now. In fact, the private sector, the private developers, they are starting to push into this area quite aggressively. So they do ask a lot of manufacturers for surveys, whether they have this or not, do you have that or not, are your products certified or not, and things like that. So it's getting there, but it will take some time. Generally, I would say the market right now, some companies are ahead than the other, but generally I would say that it will still take some time to develop to reach where we are. Ideally, in my opinion, in the future, the EPD will be in our daily lives, which means that it will come to a point where whoever or whatever product they're dealing with, whether they're from the skin of the building, from the M&E, from the structure, from the finishing, interior, and everything, all will have that. So you can obtain this easily directly from whoever that you're getting it from, or it can be hosted online where you can actually download it and search for it easily. So in fact, in the Europe, it is easily available online. So you just log in and then you just search, it will appear. Whether you search by product, search by brand, or something like that. But in this part of the world, I think we are not there yet, but slowly we are getting there. Yeah, I hope I answered your question.
Okay, we come to the end. Once again, we would like to thank you, our event sponsor, Kanaf Sdn Bhd, as well as our speaker, Mr. Brian Wong, and our speaker, Mr. Architect Chong Siong. Please give a round of applause to both our speakers.